Okay, hello everyone. Is my microphone working? Yes, it is. So is my camera. I look white as hell with this light. Hold on. I mean, I am, but that was a bit excessive. Okay. Yes, we're live. Hello everybody. We're doing good. It is Sunday. I hope you all went to Rust Church this morning. Because today we're writing Rust. No, we're not. No, the fuck we're not. I think someday I'm gonna have to try Rust. Feel like it's gonna be inevitable, but it's kind of gonna be like when I tried Windows. I'm just gonna complain the whole time. Pretty much. Went to C Church, I need that on my exam fair. Also, you tried Zed. It's pretty nice. It's pretty nice, I have to say. They did a really good job, and it's done in Rust, so can't really laugh at the language all that much. The biggest issues I have with Rust is the syntax and the community. Mostly the community, but everything that I've seen in the syntax is just like, could you have made it maybe a little bit less ugly, please? Anyway, today we're designing a language. We're not complaining about Rust. I just think someday I should use Rust because exploration. You know how it is. Same way that I tried out different code editors, even like NeoVim and Micro, knowing that I wouldn't necessarily like them. I wouldn't really use them on a day-to-day basis. I use Micro whenever I need a little bit of like code editing. And actually I need to install it on my laptop because I kind of miss it sometimes when I need it. But I kind of knew that I wasn't going to use them as my daily code editor. But I still tried them. And when I want to make a code editor, I already know what's good and what's bad about most of the good options out there, and I can take inspiration from them. In the same way, I should do the same thing for Rust. I've already tried a lot of programming languages, and frankly, I'm not interested in doing the same thing that I did for a code editor, like trying one out each hour and then one out each stream until I pick one, because that's not really my goal. But just like checking them out a little bit. I did use Emacs, but not like Zosin. I used it. The first round was default experience, and Emacs's default experience is so bad, it didn't even make it into consideration for making it to the next round. It was ridiculous. I know it can get quite good, even though Zozing himself and another guy that I know that uses Emacs, both of them, I've heard them say, like, please don't use Emacs. Don't be like us. Don't make the same mistake. But at the same time, they do it while showing off the cool things that the editor has. It's just like incredibly complicated. But yeah, I've definitely heard him say that. He even has a video, I believe, on his YouTube channel for it. Telling people, like, don't use Emacs. It has all this cool shit. It's not worth it. But it's already too late for me, but you can still save yourself kind of video. I knew that it was somewhat like unfair to judge Emacs based on its default experience, but you know. Let's say that I am on a completely new computer and I want to get my code editor working. If I have to spend like 2 hours configuring the code editor, nah. Let's say that like all my data gets wiped, my dot files are gone, and I have to start from scratch, default vanilla experience. How much time does it take me to actually get it to a point where I like it? For Zed, nothing. I have a theme. I could do without a theme. It's totally fine. And I think I had to get an LSP for make, maybe. I think. Besides that, yeah, very little configuration. Whereas the Emacs is like incredibly complex for that. But either way, yeah, that was for the code editors. Now I should do the same thing for languages, kind of. I mean, I wrote a little bit of Zig a while ago and I liked it. I can't say I saw anything while I was writing the language that I was like, whoa, my programming language needs to have this feature. Wow, I'm so glad that they did this. It's an okay language, don't get me wrong. It looks perfectly fine. It looks cool. It works. Actually, one thing that I do like is that they're explicit about allocations. You have to specify the type of allocator that you want. And maybe that I like, but that's not even a language feature. That's more so a library feature. Right, so that's why I wouldn't necessarily count it as a language feature. So yeah. R.I.P. Terry Davis. Where was I? Yeah, that's pretty much like my opinion of Zig, for example, but I feel like I should write a little bit of Rust just to see what's up. Maybe even on the website. I've technically done it on the website. But yeah, just, you know, what can I learn from Rust? Probably not a whole lot by doing it for a couple hours, but you can watch me complain, I guess. This is content for you guys. Jai when it comes out. Fair. That's another one I would try. Yeah. Odin, I've heard things about, but I haven't tried. I don't even know what it looks like, actually. Hold on. Let's take a little peek at what it looks like. Firefox is so shit. Every single time I open Firefox, it has trouble restoring my session, but then you click this button and it restores my session. Fucking vibe-coded crap software. I probably need to specify a little bit more. No, this is not it. Oh, it's better than Chrome. That's why I'm using it. Even better than Chromium. It's still just not good. Chrome is malware. Chromium is, I guess, not. Is this Odin? No, this is not Odin. What the fuck is this? Does Wikipedia not have an entry for this one? This is Odin. Okay, that makes more sense. I'm hearing people talking about it being like a modern systems language, but more so oriented towards games and not super opinionated, more so like fun. But it definitely didn't look like that. C3 I've heard about. What's FB? Jester, are you starting already, bro? Oh. He just comes on here to lick himself. Functional programming. Oh, okay. Yeah. I would do a little bit of functional programming in my language for that matter. Maybe I'll do a Swift stream. Just show Rust how you're supposed to do it. Too many languages at this point. I'm gonna make my own perfect language. Boom. Now it's too many languages plus one. What's the XKCD with the standards? Somebody commented in one of my videos when I made a build system, but I don't remember what it was. Yeah. There are 14 competing standards. We need to develop one universal standard that covers everyone's use cases. There are 15 competing standards. Time to build the language. Same problem with build systems. Yeah, my goal, keep in mind, when I'm making a build system, when I'm making a programming language, is to make something that works for me. If it also works for you, congratulations. CMake did not solve the problem either. Nah, it just fell flat. Is those an approach when it comes to languages? What is it? What's going on here? they wrote a program to just handle this accumulator. It's a little machine. Defied the laws of CMake and built knob. Oh yeah. Fuck CMake. No, I did the same thing. I made my own. And for that matter, in my it's done in C, so you know it's not the best language for these types of things. A build system could benefit from a declarative syntax. So one of my examples for what my programming language could look like, red build, is the declarative version of my build system. It's not all of it, it's just a couple functions that I copied and I translated to my language just to see how I would do it. Right? That's what this examples folder is. The other thing that I did is this kind of object-oriented stuff that I wrote 2 days ago. I also did it. This is how I would do it in my language. Odin. Odin looks nice. Maybe, okay, maybe some days we're gonna do some other languages now that I'm exploring languages, you know, like I did with the editors and like I did with Zig that one time. Yeah, just like write a language for a bit. And if it can be done completely online, prefer to do that. And I actually really like what this little hello world example that Odin has going on. It's pretty useful. It shows you string manipulation, which is tends to be pretty opinionated in languages. It's pretty full-featured, and it doesn't have anything particularly complex that requires a lot of setup or a lot of learning to do something like this. So I really like the example that they did here. I'm actually gonna bookmark this as a hello world example. You make a little programmable machine in the language. Oh, my foot is cramping. What the hell? OOP plus FP, that's Swift. But also, yes, I do plan on making it a little bit object-oriented. My foot is still cramping, Jesus Christ. Oh, this really hurts. Damn it. So like, sometimes object-oriented can be useful, and so I was thinking like, at the very least, interfaces. So I can have multiple objects conform to the same interface and communicate with them in a standardized way, but without making them, without doing inheritance and stuff like that. You know? Actually, this example that I did, I realized last night that was a little bit flawed. I'll talk about it in a second. When I explain what has happened since the last stream, because it's been a lot, actually. But before that, what is OCaml? Because I've heard about it. And pretty sure, actually, the first Rust compiler was built in this. I was just watching a Zozing video when he explains that. He said that the first Rust compiler was built in OCaml, an industrial strength functional programming language with an emphasis on expressiveness and safety. Today's video, yes. You know what? Let's save it too. All right, I'm gonna start bookmarking languages that I'm gonna try out, and if they have a little playground on their website, oh hell yes. Okay, so I'm gonna make this one Odin. Gleam. What is Gleam? Maybe, depending on how much I get done today and whatnot, I might start with the first of these. Wow, why does it look so cutesy? Oh my god. A friendly language for building type-safe systems that scale. Nil. Ooh, that's a word that you don't hear outside of Swift all that much. Alright, let's just give you a try. It's just called Gleam. I guess I'll save Swift as well, because I already know it. I'm already very familiar with it. And for that matter, I like the way that Swift is done in terms of syntax, mostly. And kind of in terms of philosophy, it actually does that multi-paradigm OOP FP type of thing. Not super data oriented. That's maybe the one thing that it's missing. Can it compile to JavaScript? Nil is also in Lua. So Jai is another language that I'm not gonna be able to check out, but Golang. Heard a lot about you, buddy. But I know nothing about you, buddy. They all kind of look the same. Not gonna lie. It's Funk or FN. Nim is basically small c. Made by the OGC creator? Is it? I thought it was made by Google. But it's not made by the entity of Google, it's made by someone. Rob Pike. Yeah, right? And Ken Thompson, maybe? Oh yeah, Ken Thompson is the guy. Lean for theorem proving. I was considering something like that, so thank you for the suggestion. I already saved Go. What's the other one you said? Nim. The ultimate app for AI video production. Oh my fucking god. Nim programming language. Right, let me open some of these because y'all are going too fast. There's Slim programming language and the Agda. What a name. Yo, buddy. Oh well, this is for theorems. Right. Suck N, suck M. I was considering what a language like this would look like, so gonna save you two. Haskell I've heard about, I guess. Modding games in Rust or some? Are you talking about the game Rust? I have a lot of work to do, okay, to look at all these. Rust games. Games written in Rust. Then. Agda has suck and Lean has grind. Jesus Christ. So, Agda is a sucker language and Lean is a grinder language. Cool. Chailang. An Adrak flavored language. I feel like we're speaking a different language at this point. Bowl. What the is this the one? We are actually speaking another language, right? Rye. Okay. Embedded scripting for Rust. Interesting. They have an online playground. If I have to do this to get your syntax, that's not great. But better than Julia. Julia doesn't have their syntax anywhere on their website. You don't know what the language looks like. Nobody, but they built an entire website and they were like, for a programming language. You know, the one that we made and we're very familiar with, but you're not familiar with. So we're not going to tell you what it looks like. They built an entire website like that. I'm kind of hoping the website is at the very least a little bit vibe coded, because that would explain the complete lack of logic in that. I don't know MATLAB. Oh wait, MATLAB is. I've heard a little bit about. Oh Jesus, fucking website. Oh, I smell the corporation. I recommend checking out Weewa. Ooh ee ooh ah ah. That 1K US dollar. Jesus Christ. Weewa. Weewa. I would rather call it ooh ee ooh ah ah and just leave it at that. What is this fucking hieroglyphic shit? You might as well have made a programming language out of emojis. Fucking knew it. It's easier to do it with emojis. Brainfuck? Nah, chill. Chill. Julia has examples on the front page? Oh, maybe they've updated it. What does Haskell look like, by the way? Yeah, I need to know what the fuck. What is this used for, anyway? Purely functional. Type classes, type safe operator, overloading monadic input and output. We're good. Do we need to include this? Yeah, you could do it too, but like the entire programming language being built around that is a little weird. Julia Roberts. Fortran. That's the first language I learned in university. Well, they've updated it. They've updated their language. This wasn't there before. This was not there before. Oh, would you look at that? Their language is actually beautiful. If only they had bothered fucking putting it there. Okay, Julia. Python. Isn't this essentially the successor to Python? Why is my nose itchy? I Piet. Alright, this is the last one I'm checking out, otherwise we're just gonna be here all day. It's an esoteric language. Wait, I was gonna say there's no example of it. And then I realized this is the example of it. Suck Python. I was like, yo, where's the code? Oh, here it is. Wait, I saw this the other day. Apparently, at some point or another, was it Ken Thompson himself? I don't know, but somebody was discussing using white space as an operator in C++. The one thing that could make the language worse. It was just a proposal. It wasn't actually a thing that was ever done, but like, I feel like it was a thing. God, I don't remember. I saw it on someone else's stream, and then I googled it, and I found it, and I saw the PDF, but I don't remember where it is. Have you used any Lisps? Well, they say that Spanish people speak with a Lisp, but besides that, no. Also, it's not true. It was a Lisp. List processing. Alright. No sound. Oh no. Oh, you can't hear me then. Let me see examples. We're done, okay? We're just gonna leave it at this. We're gonna check out Odin, Camel, Rust, with a little face. Gleam, Swift, Golang, Agda, Rai, and Juliet. The names kind of start devolving at some point. Common Lisp, Scheme, and Closure. UXN. We can skip Rust. I feel like we should look at it. Same way I wanted to skip NeoVim. If you remember when I checked out NeoVim, it was like an hour of using it and I was just like, oh my god, can this hour just go by faster? Closure. Thank you, Rick. But you have any examples of your language on your fucking front page? No? Not on the overview either. I'm assuming the reference has it. Okay. Did attempt to be inspired by Malbolge. I heard of that. Is that the one that's like super... Like they didn't even know how to write a program in it? They had to make a generator to write a program in it? Something like that? I seem to recall that. God, they make the syntax for some of these languages so fucking abstract. They didn't know if it was Turing complete. Well, fucking obviously. This is kind of ugly as fuck. Yeah, so no thank you. Wait, as in they still don't know if it's Turing complete. Okay, so I'm checking out those languages that are bookmarked. Maybe I'll start the first one at the end of this stream. I don't know. But turns out a lot has happened, like a lot, in between the end of last stream and this one. So first off, I made a mistake in the code that I wrote this weekend. And it's that I created a code generator, right? Where you register an element or an element of your... Okay, now hold on. Let me explain from the very beginning. When you're writing code, the compiler first syntactically analyzes it to make sure that its structure is correct, then semantically analyzes it to make sure that the meaning is correct. You know, all variables that you reference exist, all functions that you reference exist, all types are correct. You're not assigning a string to an integer unless it's JavaScript, in which case fucking do whatever you want. And make real programmers cry. But lol code seems like something I want to check out. I'll look at it in a second. After that, usually you create some sort of intermediate representation, which is the compiler's own representation of the code. It doesn't matter what initial syntax you wrote the program in. It doesn't matter whether your language is strongly typed or not, whether your language uses func or function or just a type. It doesn't matter whether your language is object-oriented or not. Well, maybe that matters a little bit. I guess it depends. But all of that internally gets translated to this intermediate representation. And the way that I did it is, you know, the elements of the language get registered into this intermediate representation, which is then handled by this type here. Which is why I did a little bit of object-oriented programming, because the different elements of this intermediate representation need to be registered in different ways. right? When you have a declaration of a variable, you need to keep its type, its name, and its initial value. When you have an assignment, you need to have the variable that you're assigning to and the value that you're assigning to it, but not the type, for example. So there's slightly different things, right? Even though you could actually merge those two together, but the way that I currently did it, you don't. But eventually you will, because I want to make this intermediate representation as simple as possible. And then I made it so that it emits code, because I want my compiler to generate C code at the beginning. We don't do type checking for the time being also, no. We barely even do symbol checking. I'll have to expand it to do that. But right now it doesn't really do that. I mean, you can't use variables that don't exist because it will generate an error. But if it succeeds, it doesn't do anything with them. And it doesn't check that a function exists, because technically you could reference functions that aren't in the code because they exist in the C code, but not in the CRED code. But either way, building this intermediate representation and outputting C code are separate things, whereas I put them together. So this is what registers them, and this is what puts them together. So I kind of need to split those two things apart, because, for example, if I want to do some type of optimization, right, there's a function. I want to check if a function that you declare is being used or not. If it isn't, I'm just going to get rid of it, because it's not accessible. It's not necessary to run your program. So we can get rid of it and optimize your program a little bit. If there's a variable that you declare but you don't use, I'm also going to get rid of it, or not. But I can tell you about it. I can be like, hey, this variable here, you're not using it, just so you know, kind of wasting space in your code, which is done by static analysis. Also, a lot of the memory safe languages, like Rust, actually do a whole lot of static analysis for type checking and memory checking, to make sure that you don't do some fucky stuff with memory. All of that is done with static analysis, and static analysis relies heavily on the intermediate representation. Because, again, it doesn't matter the language that you write as an input, the text, because that's what code is, it's text. What matters is the meaning of it, which is represented in this internal structure for the compiler, this intermediate representation. So the generation of the intermediate representation and the generation of the final code, the C code, should be separate. Because maybe in the future, I want to replace it. Instead of generating C code, I want to do static analysis. Instead of a static analysis in C code, I want to generate assembly. Or I want to generate an LLVM compatible code, because LLVM is a backend for compilers that can handle turning an intermediate representation into executable code for all the different architectures. So it doesn't matter if I'm targeting x86, ARM, RISC-V, I just pass it off to LLVM and it does its thing. To do that, I need to use its intermediate representation and let it do its thing. So instead of outputting to C, I'll output to LLVM IR, intermediate representation. So this should have been separate, whereas this is always the same. LLVM also does a lot of optimization, yes. Also, if I want to do optimization, that's another thing. I want to build a static analyzer for code. I want to build what I said, output into C so my code can actually be compiled. Maybe in the future I want to target LLVM, or I want to make my own backend. I want to make my compiler be entirely like self-contained. To do that stuff, then the generation of the intermediate representation and the outputting of the C code need to be separate. I realized this mistake. So I put a little error here so we could fix it, but I already did it. So I'm gonna get rid of it. And kind of what I did, just very, very quickly, is I separated its logic. Now in the C code gen, this is no longer C code gen actually, it's code gen. And I don't have the latest changes here, so real quick. This message we still need to look at, but I need to pull the latest changes, which this entire file will actually completely change. What just happened? I changed this folder, so something's wrong. I must not have pulled the latest changes. Cred. It's not that I didn't pull them, it's that I didn't commit them. So just a second, let me do that. Does it work? Question number 1, does it work? Yes, it does. Okay, number 2. Okay, stage that, commit that, push that, and pull. Okay, yeah. So I moved the C code generation to its own thing and the intermediate representation to its own common thing. I could technically make it a little bit better, a little bit more dynamic. I just cannot be bothered right now. So it uses the same like macro that I used before. If def code C code gen, here you just define if you want to use the C code generator, the debug code generator, which just doesn't do anything. But yeah, it could theoretically just generate a debug view of what the program is doing without actually outputting anything. The C code generator, which would output, or you could use a static analyzer, all of those things. Z is pretty good. Honestly, probably the best on Linux. I have to say, there's plenty of options on Linux. Z is really, really good though. So yeah, all the code emitting stuff is here. Then of course, there is this, which is the same as the to-do that I just replaced. But more changes that I made before we actually get to what I did. Does it have a debugger? I think it does. I've never used it. Pretty sure you can set up a debugger for it. I see a run thing here, start debugger. So yes, you need to do tasks.json, debug.json, probably similar to how you do it in VS Code, for example. So the answer is yes, but I haven't tried it. Another thing that I did, I added optionals to the rule generation. So for example, in my language, you can, these are actually all the possible ways that you can declare a function. You can do void plus the name of the function, or type that the function returns, plus the name of the function with no arguments, and no parentheses for the arguments because they're not needed. So you can declare a function like this. You can declare a function like this, which is like you would in C, with the type and the parentheses, even though there's nothing inside. You can do it without the type, which defaults to void, and with arguments. You can do a full one. I was also testing that you can do empty blocks because you couldn't do that before. Now you can. And you can even write just the function name, which is a void with no parameters. So this is also valid syntax. These 4 different possibilities used to be 4 different rules. Now it's just 1, if I'm not mistaken. Function declaration, optional type. So I added this little symbol for optional. Name, optional arguments or parameters. Brace, scope, block, scope, and brace. Editor is Z. And internally, what my code when my rule generator is doing, it's just doing all the possible permutations. So one where all of these rules are there, one where this one is missing, one where this one is missing, one where they're both missing. So really, it's just generating 4 rules from these 4 possibilities. Eventually, I will move the logic of that from the code, from the rule generator to the parser itself, but that probably requires a little bit of restructuring of the parser, which I'm currently not super interested in. I wasn't interested in doing that in an evening, essentially, because I did all this yesterday. But now it makes it a lot easier for me to experiment with what my language looks like, because I can put optionals with just that. Also, yesterday I kind of realized the code generator kind of broke if some of these rules weren't marked as, you know, with rules for generating their code. Now it doesn't do that anymore. Essentially, if a statement doesn't know how to generate code, but these do, so it just defers to them, pretty much, which was an error that was happening yesterday. I kind of removed it, so I don't have to do that anymore. And finally, these names are no longer hard-coded, which was kind of a big issue. Every time I created a new rule, I needed to also create its enum that used to be here. Now it's still created so that I can read the rules that are generated using their names, like function call. What does it do? It has a function. Well, it has an identifier called func. It has a left parenthesis. It has a rule for arguments called args. It has a right parenthesis, and it has a semicolon. That's what a function call looks like. And you can still read it like that because the enum is created up here, but it is not used outside of here. And there's also a little function, well, a little array at the bottom that just generates a string so that you can still read what the parser is doing in a little bit more readable language. But finally, they're no longer hard-coded, which means I can create as many rules as I want now. Okay, that was a lot of changes. But yesterday, I did see a limitation with the code generator. Quite a big one, too. And it's the fact that my string manipulation library is, for the time being, limited to creating strings that are 256 characters long. Wait, I gotta remove that error if I want this code to run. So, you see, this code is quite extensive. It's 337 characters. The C code is even longer, so it kind of cuts off. Because I'm using format strings to create the C code, which is stupid. So today we're gonna make the code generator properly work by emitting code instead of just using a string format. And that way I'll also be able to hopefully do a little bit of formatting, because this code translates to this kind of block of code. So a little bit of formatting would be nice to have. And that's actually what this error refers to. So today we're going to be fixing that a little bit. We're going to be making a code formatter. And actually, keep in mind the compiler is currently made up of 2 different compilers in a way-ish. To call the rule parser a compiler is a strong word, but it does analyze text and produce an output in code. So it's very similar to what my actual compiler is doing, which is take in text, even though it's code, and then analyze it and produce output in code, which is C code. So I can start merging them a little bit. The code formatter is going to be the first part of that. Okay. So that's kind of what I want to do. Instead of using string format, I will use output code. And actually, I'm going to copy some code from the rule parser, which it says here has an error. I don't see it, though. What are you complaining about, buddy? Linked list. It's used right here. Okay, I'm pretty sure it's just a little dumb error from Clang, but everything compiled fine, I think. Yeah, I did. So we're good. All right, so I'm gonna do this code formatting thing, and then I'm going to start experimenting with the language a little bit more. Now that it's so much easier to do it because I have optionals, and I can use as many rules as I want with whatever name I want. The name of these literally does not matter anymore. It still generates the same code, as long as you're being consistent within this file. Okay. So we're going to create a code format.h, and this one is going to handle emitting actual code. This one's going to take strings and put them in a buffer and create that kind of stuff. So I already have this emit function, which is being used by the rule parser, which is the other compiler, the one that compiles the rules for the real compiler. And like I said, we're merging them a little bit. So ideally, the rule parser will start using this code formatter that I'm going to be creating today. So the code formatter creates an emit function that just takes that. Does it have anything for new line, I wonder? No, I didn't include anything for new lines. So I wanted to quickly emit a new line, shorthand for whatever that is. And since it's a code formatter, it... All right, something fell, so I'll be right back. I think it might be food, so gotta be careful with that guy. It was. And just in case it wasn't clear, there's a dog under that. So when I said that guy, that's who I was referring to. Okay, back to the code formatter. If you're going to be formatting code, you should have functions to increase and decrease indentation. You thought your food arrived? Kind of. If you live on the floor of my kitchen, maybe. Okay. So these are the 4 functions that I wanted to have. And then I will rewrite the code emitting code. The code that emits code to use this code formatter. And also to not use the string formatting anymore, even though the code formatter I'm pretty sure internally uses that. This one is going to be unaware of what code is actually outputting. It just outputs text, but in a formatted manner. Formatted meaning new lines with indentation. Pretty much that's what it knows about. And the rule parser will use it internally. So I can get rid of a bunch of... Can you listen to me? I'm typing in you. There. I can get rid of these ugly manual indentations that I'm doing here. And clean up that code a little bit. As the first step of combining the 2 compilers. Kind of. And I was thinking, and I think definitely... obviously, this is the first version of my programming languages compiler, which has the advantage of having a code generator. Sorry, not a code generator, a rule generator that makes it easy to iterate through the rules of the language and prototype the language, what I want it to look like. Change the syntax with just one command. And so I want to keep this compiler as a prototype language compiler. So not just as the first version of my language, but also as a prototype compiler. Code formatter. So much easier to just make it than to integrate an existing tool. It's literally gonna be a very simple program. The emit function is already written. It does use string formatting internally. And it outputs to a buffer, so I'll have to change that eventually. There is also, the parser currently has it. It's in rules.h, I believe. No. It's in one of these headers. Is it parser.h? No. Common.h. Okay, here. I have some functions to handle indentation automatically. So I can just include common.h. And essentially, emitting a new line will, you know, this, oh, well, no. I'll create an emit constant because that's kind of useful to have. Although this one actually just emits n and then s indent by and then the depth that is going to be tracked by this and this. Right, so let's make a depth variable, depth plus plus, depth minus minus. What else does it have? It has this, plus it has a maximum size for the code that it formats. I guess that's fine for now. All right, so it's a very simple code formatter. You just emit code using a format string, you emit a new line, and you automatically indent whatever comes after the new line based on the current indentation, which you can increase and decrease. Technically, a code generator is a little bit more complex than that. I mentioned yesterday how sometimes you actually want to output to different levels. So I mentioned yesterday, for example, that when I declare a variable here, what's really happening is at the beginning of the function, some space is being allocated on the stack, and at the end of the function, some space is being freed from the stack. So when you emit this, you also need to emit here and here. So in reality, the code formatter gets a little bit more complex than this. It should also be able to handle writing to multiple buffers, keeping track of multiple depths in each of these buffers. Probably, I'm not entirely sure about that one. Yeah, it should. So I will want to do that. Essentially, these variables, hold on, let me make it a little bit more readable. These variables just kept in a state variable that gets changed around. You can target multiple ones and whatnot. But I don't think I have any need for it right now. I will eventually, once I have things like lambdas, for example, because I can declare a lambda inside of a function, but when it comes to emitting the C code, that lambda would actually be generated outside of the function. So again, the 3-layered thingy that I said applies here as well. Things like defer as well, which I want to have in my language, means put code at the end of the function. So I will have to handle multiple buffers to write to, but right now one is fine. And no, I want the C code to be human readable, because I wanted to integrate into my existing code base, and also I want to be able to see the correctness of the code that I'm writing. For debugging purposes, for the time being, it's gonna be readable. If not, you could literally just make it so that this, and this is ignored. And then, yeah, you'd be good. Okay. There's an ad starting on Twitch, but for the sake of simplicity, since we just started, we're just going to very quickly write this function. It's bigger or equal than max buff. Just gonna return. It's not really an error because there's not supposed to be a finite buffer to write to. If you want to write a lot of code, you should be able to. Just right now, for the sake of simplicity, I've made my buffer that I write to static, and so it has a maximum size. But normally what we want to do is we want to write No, actually, this symbol is not necessary. Kind of just do that. Okay, so I have a very simple code formatter. And turns out implementing this function was a lot simpler than I expected. Well, I wasn't expecting it to be complex, but it ended up being very simple. So we're going to wait for the ad to finish on Twitch. And then we're going to continue. I feel like the code formatter, there was one more thing that I needed to add to it. I completely forgot what it was. New lines, indentations. Well, if there's anything else, I guess I'll figure it out as I'm writing the code. Well, no, yeah, okay, I remembered. It's just exposing this function so it's available outside of the file. Oh, and the stack program thingy that I said, the multiple layers and whatnot. That is going to be important, but right now it really isn't. So let's make sure that this works first. Rewrite the code using this format and then think about that. Or I'm not sure. Yeah, no. Okay, let me not complicate things too much. I think I'm just stalling to wait for the ad to finish on Twitch before I continue. Quality is geolocked? What? Quality on Twitch is geolocked. That is ridiculous. Also, yeah, I'm streaming at like 3000 p, but it is being limited to 2160. So that's great. Okay. Wait, another thing is... Okay, yeah, these functions are just called emit, because there's also an emit code function, but that's a different one. Okay. All right, so 20 more seconds. Surprised that it's... Well, you're at 720p. Yeah, feel free to move to YouTube. I usually do ad breaks, this time I'm not, but yeah. Quality is geolocked because of lower latency. Twitch encodes on a local server. It's kind of dumb. All right, we're back from the ad break. So feel free to move to YouTube. if you so wish. I sent the message to both chats, but yeah, it actually works on YouTube as well. Okay. That's why I was complaining when you streamed Hytale. Oh yeah, you said that. All right. So the code formatter should be there a little bit. Of course, there is one more function I need to write, which is the output code. And do we want it to output code, or do we want it to just write it to a function? Is this one just writes it to a function? Write full file. So maybe I'll just do that. And eventually I'll configure it again so that this rule parser just uses this code formatter internally. So this will have to be configurable, but output.c with a code buffer and the cursor, we just need to include syscalls for it. Oh, YouTube is a little bit delayed, yeah. That's the issue with it. If you want low latency, you have Twitch, but lower quality. If you want better quality, higher latency, you have YouTube. I actually cannot even change the latency anymore. VPN time, is that gonna make it better? Okay, anyway, the code formatter should now output to this output.c file, which is fine for me. Okay, but we have to try it. We have to make sure that it works. So right now the emit code function returns a char, but just to test that it works, the way that you should output code is no longer like this for a block. It's now you emit the code for the code statement that you have in this part. And then you emit the code for the chain, which is itself actually a code emitter, so this one doesn't need to keep track of the char. And the cool thing about it is we can just emit const st if we include code format.h. We can emit const, which uses still the traditional method of string format to generate each statement, puts it on the buffer using the code format, and then emits the code with this. And this just returns nothing because eventually I will make this return a void. But I need to change all of these functions, but first I need to see that it works. So we go to the IR generator, and you no longer print the emit code. You instead just emit the code, and then you output, hold up. Output, no, right, what did I call that function? God damn it. Oh, I didn't even expose it. It's called output code. So you emit the code and then you output the code. How is it undeclared when you're... Oh wait, no, it's code gen rules code format.h. Okay. That failed because we have multiple definitions of cursor, so okay. Let's call this one a code cursor instead. This will stop being a problem once I put this stuff inside of a structure, like I said I was gonna. Okay. This is a message that I need to get rid of. But we have an output.c that, yeah, it's here. But since I'm not emitting any new lines, I kind of forgot that part. So hold on. Emit new line. So statement, new line, and then the rest of the code, which is recursive. So it's the same thing. What? Oh, wait. If I output as output.c, the build system will then pick it up. But I do have a build.config file that I can tell it to ignore files, and I should be able to tell it to ignore output.c. Yes, perfection. My build system works. Although I want the build system to work in code, not really in like this. But it's not bad. It's, like I said, declarative code. I want it to be declarative code. Hi, Stoney. So now we look at it, and there's nothing in it. Yep. What happened? It was there a minute ago. Before I emitted the new line, it was working. It stopped working entirely now. That's not... Ugh. It was outputting. There it is. It was outputting, but the version that I had here had local changes that weren't saved. That's why it was empty. Okay. Now it generates code like this, which is not super correct because there's a bunch of new lines in here as well, if I'm not mistaken. No, actually. So why is it generating 2 new lines? Oh, wait. Yeah. The emitter was already internally generating new lines. That wasn't supposed to do that. So, okay, now my code looks like this. Not the cleanest, but it is not correct. I did something wrong. Well, it's kind of the fact that this is now outputting in one direction, the rest of the code is outputting in another direction, if that makes sense. So I think that's being a little bit weird. So yeah, like this code goes in here, but because this is using a different rule generation, code generation rule than the rest of this, it's doing it backwards from the rest of it. I either change all of it or this is going to happen. But I need to change all of it. The point is, it generates code, it looks fine, and yeah. Now I need to do these. Okay. So we want to output... Wait, another thing that would be really useful is to emit a token. Since we know that we're working with tokens, we might as well do that. But also emit a string slice. Which are very similar functions. Except I need to include their types, which are std string slice and data tokenizer. I've mentioned I need to rearrange that library a whole bunch, I was waiting for a pull request that just came in a couple days ago, so I should probably do it. Either way, slice data I. Simple as that. T length, T start plus I. Like that. We now have a very simple emit token, emit slice, which is going to be helpful to write these. Okay, so when we have a declaration, how is a declaration done? We emit a, well, first off, to do a declaration, we should fetch from symbol table, because there's a reason we should be building a symbol table, except we're not. So we're going to skip that part for now, but I'm going to put a to-do there to remember that. We're going to emit a token, which is going to be the type. We are going to emit a token, which is going to be the name. I'm pretty sure I'm not emitting spaces, so that's kind of an issue. And we are going to emit the initial value code. I'm going to be doing this a whole bunch, so all of you guys will no longer return, and you will no longer need to do this. You kind of just work like this. All right, so big refactor coming up. What about when we have an assignment? An assignment is very similar to a declaration. For that matter, if we were writing a different kind of intermediate representation that wasn't C, we could just make them the same thing. But we are doing C. So the ask code is separate from the deck code. But anyway, we emit a token, we emit a code, and you know, useful function to have here. We emit a type space name. Then we actually emit this. We need an equal sign. Then we emit that. And finally, we emit a semicolon. So this actually emits the same thing. The name of this is different. What about calling a function? We emit the name of the function as a token. That's code name. Then we just have a parenthesis. Inside the parenthesis, we have the arguments, which can be empty. We have a closing parenthesis. And right now we have a semicolon that technically isn't necessary. Okay. To emit a conditional, we have the two codes being emitted here, which is the condition and then the scope inside the condition. So we emit No, we emit the if. We don't write the word if. If, open parentheses, the condition, closing parentheses, open brackets. After that, we increase the indentation. We emit a new line. We write the code that goes inside of that. We decrease the indentation. We write the closing bracket, and we emit a new line as well at the end. Okay. What about a jump? A jump is a very simple structure. That's just the word go to, the label that we're jumping to, and then a semicolon at the end. Okay, almost done? Ish. Not quite. All right, actually, we're kind of almost done here, as these are simple to do. We emit, thank you. The code name for a label, so a label for a goto, which, by the way, I'm gonna remove gotos from the actual language. The reason I have them right now is because I was trying to make the smallest possible Turing complete language. It technically wasn't even Turing complete. It relies on a function to write to memory, to specific places in memory. But hey, mostly Turing complete. Turing complete-ish. Turish complete. Yeah, Turish complete. Okay, to write a label, we emit a label. I mean, a name. We emit a semicolon, and we actually increase indentation. That's not really correct, technically. In reality, because the thing is that when you're writing a label, you do it like this. The label goes here, but the code stays the same. But just to kind of like do the formatting the way that I did it, I'm okay with doing it like this for now. Can't waste too much time on formatting on the very first iteration of this. All right, what about an expression? An expression is where it gets a little bit complicated. Because, by the way, I put a to-do for fetch from the symbol table in a declaration. We should also do the same thing here. The expression also needs to do the same thing. It shouldn't just write the symbol as it finds it. It should get it from the symbol table. That way you can do like type inference and whatnot, which my language supports, but C does not. Okay. An expression is made up of a value, an operand, and an expression, or just a value. So it's kind of easier to emit code with this format than this format. It's going to be cleaner. First, we output the value of the expression. Then, if the expression has an operand, well, no, if the expression has an expression, oh, okay. We also output the operand as a token and the expression as code. So emit token code operand, emit code expression. I feel like that is a lot cleaner. And we don't return anything. What about function arguments? Again, somewhat easier. We first emit the code for the expression, which is the first argument. And if we have more arguments, we already have the if statement, so we might as well keep it. Then we emit comma space, and we emit the code for the next argument. Void. All right, 2 more left. Let's go. We're almost done. Function parameters, very, very similar to function arguments. They're the same thing, just on the other side, on the declaration side. The difference is they have a type. But the code is incredibly similar. So we might just be able to save this, except type name chain. We first emit the code type. Then we emit the code name, which again, do I still have that? No, I don't have that anymore. It's been over a year. Damn. Get back to it. Let's go. Okay, where was I? Here. The type and the name should be taken from the symbol table, not just blindly copied around. For the reason, like I mentioned yesterday, kind of, is, for example, Swift. C uses types like uint32, which is technically not even a type in C. It comes from a header. Why do I have an antenna? It comes from a header. In reality, it's an unsigned int. Whereas my language, for example, can use u32. So just blindly copying the type that my language uses to the type that C uses probably won't work all the time. For the time being, it's okay, because I am using the same types, and also because it doesn't really matter. But I should take them from the symbol table, and I should do appropriate translations if there are some to be made. Okay, last one is emitting the function code. It's actually quite similar to emitting the what is it called? The if statement when it comes to its block. So actually, conditional, where are you? Here you are. This code, pretty sure, is going to stay the same. The difference is that scope gets called body. There we go. Before that, there's the arguments, which get emitted as code args. Before that, the name of the function. And you see, that's the cool thing. We don't care if, like I said, arguments are optional in my language. They're not in C. If you don't have any arguments, you still have to put the parentheses. So the cool thing is that this will just not do anything if there are no arguments. But the generator will still generate the right code. So at the end of the day, C is a very simple language, and that's why we're targeting C. No, we don't emit code for the token. We emit the token for the name itself, which also should be fetched from the symbol table. And for the type as well. The difference is the type is technically optional. We might not have that information. And if we don't have that information, then what we do is we emit the const void. I do realize, though, that I've kind of been neglecting emitting spaces. So my code is gonna be a jumbled mess. Let me put at least some spaces here and there. And see what happens. Wait, hold on. This is not gonna run at all. First off, I didn't delete this. Second, all my functions are now voids. And so they need to be voids. Here and here and this one as well. And this. And this, where this is no longer an error. Are we good now? No, not quite. Multiple definitions of emit token. Can I assume that both of them use token? Oh. There's an emit token in the parser, and then there's an emit token here. Right. This is a AST emit. Let's just call it, instead of emit token, we're gonna call this function AST token. Push AST token. And instead of emit rule, we're gonna call it push AST rule. Okay, that got rid of it. And our code isn't perfectly formatted, but it is quite well formatted, a lot better than before. And one thing we do see is that now the error that was there before, which is the code of the main function was outside of the main function, now it's fixed. I said you either have to commit to one way or another. That was a hybrid of doing it in two different ways, so obviously that was going to cause problems. Now that I've committed to writing my code properly, it works a lot better. I write my code like this. Can you imagine if I just constantly increased the indentation without ever decreasing it? Well, you don't have to imagine. Hold on. There's actually a limit. There's actually a limit that is reached here. I'm pretty sure. Well, I just go like a. There's not that much indentation, okay? But we can we can lift the limit. Hold on. The indentation is literally being done by a string. Let me look for it. Instead of telling you what it's made out of, I can just show you. This indent string, which is done by... God, who handles that? Here. It's this string over here of 128 characters. So there is a maximum depth of 64. And somehow we've actually reached it in this code. That's ridiculous. Okay, but the code formatter looks pretty cool when it works properly. Which even without that ridiculous thing, it didn't. So functions are not doing it properly, neither are these. So I made a mistake there. I made a mistake in the conditional, and then I copied the conditional over to the other one. So now they both make a mistake, which is that I see. The error is actually here. we emit a new line at the end of a statement, even though it might not actually be necessary. It should only be necessary if there's another statement after it. That should be a little better now. No, I messed it up even more. I mean, it's better, it's better. But what did I mess up is the fact that I forgot to put a new line here. So, yeah, it's good. One thing is what I said before about labels. They're increasing the indentation after themselves. That's not right. They should ignore the indentation. That's how they work. But they're currently not doing that. So let's just not make them do anything with indentation, otherwise it messes up. And second, in the conditional, I didn't fix the issue. So what we do here is the correct thing. And here is the other correct thing. Boom. There you have it. C code, perfectly formatted as all things should be. What do you guys use for indentation, spaces or tabs? I think I've made it pretty clear what I use. Tab is just better, isn't it? I remember that one episode of Silicon Valley where like the main guy actually breaks up with his girlfriend over that debate. Only girl he dates on the entire show, by the way. And he breaks up with her just because she uses spaces. Or does she use tabs and he uses spaces? Somebody please answer that. It's kind of important. Okay, like I said, speaking of spaces, I am missing a bunch of spaces. Like here, for example, int x is not right. It's int space x. Dinesh dating a hacker was a different girl, though. That's a different girl. All right. That's in the parameters, right? So here there should be a space. In the expression also there should be a space. Here and here. Not here, not here, not here. What is this? Call? No. What's this? Assignment. Space is already handled by this. This one, and we should be good. What was the other issue that there was? Yeah, I watched Silicon Valley like a few months ago. That's how I remember that. Okay, I think that's it. I fixed both of them, I believe. Yes, I did. Hey, Amex. All right. Here we have it. Beautifully formatted C code. It has a couple errors. In the code itself, actually, I call the parameter and the argument here the same because these functions are just they were just to test out the different kinds of functions that I said that you can declare. As I said, you can skip the return type and you can skip the argument, and they should all be void no argument, void no argument, void one argument, void no argument, void no argument. And if we look, void no argument, void no argument, void one argument, void no argument, void no argument. Good. But of course, this is not a problem with the compiler. This is just a problem in the code itself. I guess the compiler's problem is that it doesn't recognize that this is a problem. And that the draw and printf functions don't exist. And of course, Clang realizes that that's a problem. See, let me actually show what I meant. we're good. We technically don't need to recompile the entire toolchain in order to be able to do this. Now it complains that U32 don't exist because really it should be, what's your problem with it? Oh, wait, I still call this variable x. I should have deleted it. Get rid of that. And the draw function exists. Printf does not. We can create it. But this is where the problem with it comes. That will just break everything. That is a syntax error on line 7, character 16. Again, this seems to always be a little bit wrong. Character 16 is here. Wait, the off by 1 error is probably should be 17. Well, because you start at 1. Yeah, okay, so that's the off by 1 error that I see now. The column. No, who handles this? Here, you start column at 1. So it's now line 7, character 17. So it shows the error as being here, not here, but still pretty good. I was a little bit confused by that off by 1 error, but I should have seen why it was like that. Also, I'm really close to 900 followers on Twitch. In case you're not following, feel free to follow. Please consider it. Also, is what I meant. Not feel free. I mean, do feel free, but what I meant is consider it. But yeah, I don't allow asterisks, so... In order to generate proper code, I need to do it like this. And then, bro, what the hell? So Clang complains I need to do this. And then the U32 thing. And this is where the symbol table stuff could come in handy. Because my code can use U32. The symbol table could recognize U32 as unsigned integer. And then translate that to uint32, which is the type that... well, actually, C doesn't really use. C uses unsigned int. Right, so it should translate U32 to unsigned int. Ish. Because to be fair, int technically changes sizes. For the past few decades, I believe it's always been 32-bit. So unsigned int is a 32-bit unsigned integer. But the fact that C is not explicit about this annoys me so fucking much. And then long, let's not even get into long. Oh yeah, these kinds of translations should be handled by the thing. The C standard allows for the int to be 16 bits. Yeah, technically, just nobody implements it like that, but yeah. I'm also not following the C standard, to be fair. Somebody defined the language as being intersecting with C, not really C compliant. And the reason that main is a void is because I was testing out no return type. So that's why it is a void. There. It also doesn't have the argc, argv, because it doesn't handle stars and arrays just yet. In order to handle those types of things, so in order to make this not char fmt, but char star fmt, that should be handled by the type system in the semantic analyzer. I'm not saying that my language won't have that type of syntax necessarily. IDK. But I'm not sure that that kind of syntax is necessary. This could be like a literal type that my language defines. I don't know yet. The compiler is in a way kind of designed to compile any language, so it's meant to experiment with the syntax of a language, not really meant to to compile any specific language. That's just me taking the limitations of my compiler and turning them into a feature, pretty much. But hey, gotta know how to market yourself. Right, so I could introduce a literal type, which translates to char star. I could introduce a U32 type, which translates to unsigned integer. Controversially so, I guess. Because we could sit here and just complain about that for so long. And honestly, that article that says that C is not a language, it's a standard, and it's kind of a shitty one, yeah, they're not wrong. C is a pretty good language, or a pretty good standard. And hell, you can see how immediately I didn't even hesitate. My programming language should compile to C. It's my what's the word for it? Not mindless. It's an obvious choice. It's an obvious choice. If I don't want to go all the way to executable, to compiling an executable, or to handing it off to LLVM, the obvious choice, compile to C. That way, my code becomes automatically interoperable with C. It becomes automatically interoperable with all other programming languages that I can think of. The computer-based ones, not the web-based ones. Or Java. Fucking Java. But yeah, it's kind of a... God, there's a word for that. Like an obvious choice. What's the word for that? A no-brainer. It is a no-brainer to translate it to C. I didn't even have to think about it for a second. But then you run into these kinds of problems. Technically, I could translate U32 to unsigned integer and it will work on Linux, Mac, Windows, and even my own operating system. What about the future? Who the fuck knows? Who knows? What about the past? What about if I run it in an old machine? And this is a problem caused entirely by C being so goddamn flexible. That's the funny thing. We've actually been, if you look at x86 and if you look at Windows, for example, there's so much backwards compatibility. So much of it. But then when it comes to the biggest programming language in the world, yeah, we run into these kinds of problems. And it kind of sucks. It's a very minor problem, but it's a very major problem at the same time. It works on 99.99% of the cases. But I guess I just have to be okay with it not working on that 0.01%. And that's, well, that's sad. That's about all I can say about it. Okay. Well, the code generator can now format the code. And I'm really starting to notice the need to translate types using the symbol table. But it is kind of a more complex thing than just a simple translation. I could hack it together very quickly, but what's the point of that? Kind of. ctype.h. You can't run 16-bit programs on Windows today. Well, not on Windows, but you can run them. Let me see ctypes.h. Also, the header files in the standard library of C, they're so fucking ridiculous. Why is memcopy and memset in string.h? Why is alnum, is alpha, is blank, is lower, is upper in C-type? These are character functions. Why are they in ctype.h? So actually, that kind of brings me to the next question of what does ctype.h have to do with what I was saying? Yeah, I feel like you confused it with another one because ctype, I would think it's about types. Um, it's not. Windows support for 16-bit programs ended with the new 64-bit Windows versions? No. Yeah, the one that defines those types is it's not stdio. Hold on, it's I have it in my cross-platform library. I was actually like handling those cases myself, and then like when I fixed it for Linux, it broke for Mac. When I fixed it for Mac, it broke for Windows. When I fixed it for Windows, it broke for, and I was just like, yeah, you know what? Just import this header. I don't give a shit anymore. If I go to types.h, wait, I didn't realize somebody already gave me these functions for built-ins, for bswaps, I mean. Well, I did realize, I just hadn't been using it. But stdint is the one. Yeah, there it is. That's the one that defines all of those types. So like here I'm defining them for myself, and I'm just letting stdint and stddef handle them for everyone else because I cannot be bothered. God damn, these. It's been a little bit of an issue in the past. Okay. What do I have? Yep. Yep. Yeah, this entire file, I'm good with how I did it. Yep. Code formatting in here. I fixed the parser, so I need to remember that. Well, hold on. It's actually better column number. To get the correct number, you should get the position of the next token, not the position of the current token end, but still. Reached a new goal? What do you mean? I changed the name of this function and where I call it. That's good. I changed up a little bit of this, but I'm not gonna keep this. If I'm not mistaken, the old version would compile to readable code that Clang wouldn't complain about. And then output.c should probably be get ignored. Code formatter. Okay, cool, but there we go. Managed to get Quake 1 to run at a decent frame rate. You know, I still haven't been able to fix Doom. It still randomly crashes. I've looked at it a grand total of like 15 minutes spread out across 3 days, 5 minutes each. So, yeah. I'm not particularly looking forward to running Doom in a virtual machine or on a very slow Raspberry Pi 5 or on a Raspberry Pi 4 with no input. So till that's fixed, I don't care too much. Okay, I want to add a little extra. No. Okay, hold on. Did I not include the git ignore? That didn't get included. So just amend real quick and force push. Okay, I think we can start experimenting a little bit with language again, because it's kind of a thing that I've been wanting to do for a while. And all I've done is pretty much just make functions kind of more declarative looking like this, which I like. But I want to go further. I need to expand the language a little bit more, so let's do that after the ad break in 3 minutes. Okay, playtime is over. It's time to design a language. And I'm not sure what changed in OBS that I cannot see. Okay, there it is. The level meter for my microphone when I speak. So every time I switch back to this screen and I start talking and I don't see the level moving, I'm thinking my microphone doesn't work. But we're good. It was just hidden. Can I rearrange these actually to put the microphone on top? No. Can I rearrange them like this? Also no. Okay, never mind. Compiler, pretty interesting, yeah. Okay. It is time then to generate some more rules for my language, and I'm gonna get my laptop because I have a few notes here to see what I can implement. We're not particularly advanced yet in terms of what we can do, so we're not gonna do lambdas any second, or are we? We don't even have functions as expressions, so maybe let's not. Just chill. All right, chill. Okay. Um, mm, 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 mm. Okay, putting function argument names in headers. This is one. I'm honestly not sure how people feel about it. Or hold on. Should I take some time to write a language? Maybe Swift, because I already know Swift, so I'm not gonna spend a lot of time exploring the language. Though I am a little rusty in it. But maybe I could do that, especially if it has a playground, which pretty sure they do. Just to show off kind of the things that I would want to see the syntax of these languages, see what I can steal from them. So let's see if a Swift playground is available online. It's an app. I know that, but do you have a web version? Please tell me you have. Okay, there's a Swift fiddle. I don't think it's official, but hey, if it let me write Swift, here it is. With no formatting. Oh, there it is. Ugly formatting, but it has formatting. All right, so let's do that for a bit. We're going to write Swift because it actually has what I was going to talk about. Is there nothing better? Hold on, let me see if there's other options because that one was kind of ugly. I should have been on my Mac. If I knew I was going to do this, I would have been on my Mac. There's also Swift playground.run. Bit slow. No, I would never use an AI code editor. Cannot be bothered. I disabled AI on Z too. My god, this one's like a million times slower. Yeah, I'm sticking to this one. Okay. Odin has this very simple program that I decided I was gonna make my hello world for checking out programming languages. Essentially, it seems like you just write a okay, it uses emojis, so maybe we'll want to get rid of it because I'm not sure if all of them support emojis, and mine certainly doesn't. Eventually, I want to write this in my programming language. But yeah, I think it's an interesting thing to do. Write a very simple program like this one. So essentially, you have a program made out of these symbols. Then you just iterate through the string, which is the program. And whenever you encounter one of these symbols, you do a specific thing. You add 1 when you encounter a plus, you remove 1 when you encounter a minus, you add 2 when you encounter an asterisk, you divide by 2 when you find a divide symbol, and here you multiply by itself, which I'm gonna get rid of this symbol. I'm gonna change it for something else. Everything else gets ignored, and the final program gets output. All right, so this is the program that we want to replicate in Swift. So like I said, I decided is going to be, God, this editor's, no, this editor. Is it at least easy to use? Because that one was kind of, yeah, that's a little bit of an issue. All right. So in Swift, I can declare my program as a let, which is a constant. I'm not sure why they use the word let. I'm choosing Swift for the first language because it is one that I already am familiar with. And I can just do it like this. And let me see, the program was ++ asterisk ++ asterisk. Then this symbol, which we're going to replace with this one, which is usually used for power off, minus and divide. And your program starts with an accumulator at 0. Porting your theme to VS Code. Damn. Oh, yeah, theming is another thing I really want to focus on. I want to make my own code editor eventually. Okay. So I'm actually gonna make it a little bit more complex than this because this doesn't actually define any functions, and it just so happens that You have to define a main function here. Swift can also use this script-like syntax, so I don't have to define a function, but for the sake of it, I want to. Calculate a program, and it has to take in a program. Well, actually, the way to do things in Swift, the nice way, the correct formatting for Swift, you don't have to do it this way, but you can, and it kind of makes it easy, is calc program string, that's it actually, which returns an integer. Probably my own code editor is going to be a lot more limited than any of these other ones, let's face it. But yeah, it'll probably be open source. I'll have to look into how LSPs work as well, because I definitely need to have an LSP for my language. And then I have to have support for LSPs in my editor. All right. So actually, I don't fully remember how I would do this. Would I do for each? Not entirely sure. Let me just write it. How do you even do a print in Swift? Oh my god, it's been so long. I actually use it for work, but I've been doing other stuff, so I've barely even written Swift. It's mostly a lot of maintenance, so you don't write that much code, and I haven't done any projects in Swift in so long that I've genuinely forgotten the syntax of the language. If I'm not mistaken, this is the syntax of the language, which is, this is a function called for each, so I'll explain that one in a second. It's a function with a closure, so it's functional programming. But the thing that I want to integrate in my language is this specifically. When you declare a function, when you call a function, sorry, when I call calc, I need to specify the name of the argument like this. And that makes it so that I can, you know, if instead of this, I just made it like this was my syntax, then you can look at this and be like, what the fuck are you doing here? I have no idea. Whereas if I have to be explicit about the argument name when I'm calling the function, you read the code and it's a lot more readable. Oh, you're calculating a program. What is it doing internally? You have to look at the calc function to understand what it's doing. But to me, it feels a lot better to do it this way. And if you want to skip doing that, you can just do this and you don't have to include it. Or you can even change, use two different names. You can use the name that is used externally and the one that is used internally. Right, so it would be prog, and then this would be program, which probably should have been the other way around. Does this run? Did I do it correctly? No, I didn't. Yeah, the prog for each is wrong, isn't it? First off, can you even do a for each for a string? Who knows? Yeah, you can. So what's your problem with it? That's exactly what I'm doing, isn't it? For each. Oh, but I didn't. I forgot to put that in. Though it still complains. What is your complaint exactly? Cannot convert the return express. Oh, wait, there's the return type. Okay, so there you go. It prints out the different characters of my string. Why does it kind of cut off? It's weird that I can actually see here. There's a little dot that shows me that there is actually more text. There it is. I can even select it, but I cannot see it. That is so weird. whatever. Another thing that you can do in Swift, which is pretty cool, though not super necessary, is you can just do this, which is the same as doing return 0. If you only have one statement, you can just return without using the return keyword. Some other languages do this. For example, I believe C#, you can do like... Well, why would I put void here? In C# you can do this, which I think is even better. I like this syntax more than I like this one. I would like if Swift allowed me to do this at the very least. But, well, obviously you wouldn't do it like this. You would do like frog would make sense. Like, what's the point of returning a constant? None. But you get the point. So I like the way that Swift allows you to do this. And for example, when you're using these, it tends to be pretty useful. But you don't necessarily want to do this. Like, it's not necessarily the cleanest syntax when it's just like this. But there are cases in which it makes it look quite elegant. Another thing that Swift is doing here that's pretty interesting is the for each is a function. For each is a function of string. But it is a function that takes a closure or a lambda. And if your last argument of a function is a lambda, you can put it outside of the parentheses. So for example, when you're done, I want you to, instead of making this a function that returns, I can make this a function that calls a lambda. Is this the right syntax for that? I don't know. And then I can do this. Where $0 is shorthand for the first argument of the lambda if you don't declare its name here. To declare the name of the argument of the lambda, you do it like this, and then you put the word in. Not sure why in. Seems kind of arbitrary, but whatever. What did I do wrong? It's not nil. Do you return void then? Yes, you return void. And how am I supposed to know if this works if your editor cuts off? Ugh. There is the other editor, I guess. I just didn't like it. It's laggy. Just looking at it, it's laggy. I'm surprised it's not lagging my stream. But yeah. You can see that it actually runs, which is what I care about. All right, the point is, you can do this kind of syntax for lambdas, which I also think is quite useful, and it really helps in the same way that my language allows you to do it very similarly. You can skip the return type and the arguments if they're empty when you're declaring a function, but not when you're calling it. Maybe when you're calling it, I don't want to skip those, but like do something similar with the closures, and then since Swift relies heavily on closures, it makes for some quite nice looking code like this. Okay. Either way, Swift is actually quite functional, and it has a reduce function where you start out with 0, and then reduce, what it does is it aggregates all the elements of an array together. It's treating the string like an array where each of its elements is the character. right? So we start with a 0, and then for each new element, we run this. Wait, or actually this can be accumulator character, right? I can then switch on the character. It's been a million years since I've written a switch in Swift, so God knows. Does Swift do this? Or why do I seem to recall that Swift doesn't actually do this? I have a feeling it doesn't. Wait, does Swift have defer? Can I also do 0, or do I need to do return? Because this reduce should return an integer. I guess we'll be told. Okay, so first off, accumulator plus plus is not a thing. You have to do it like this. Kind of sucks. That's also not the error. Accumulator is a let constant. Oh, so you don't do that. You just return accumulator plus 1. Missing return. Okay, so I do need to return explicitly. Maybe I would want my language to have some sort of syntax that allows me to do like, hey, when this switch returns a value, always the same value. That's not always how switches are, but yeah. I can then call onDone directly on this, and you can see that I don't need to have any return type or anything like that. There we go. What I'm a little bit surprised is that it returns, well, the default returns 0, so it should return accumulator. And now the return is 2 because it has these two values. All right. The other cases are multiplier, which the Odin program multiply by 2. The minus sign, which is accumulator minus 1. The divide sign, which is accumulator divided by 2. And the one that I changed, this sign, which is accumulator times accumulator. And the result of my program is 7. Is that correct? 0, 1, 2, 4, 16, 15, divided by 2, 7-ish. It's actually 7.5. Well, what did I say? 15? Yeah, 7.5. But rounds down to 7. If instead I make it float, I think the type system should be smart enough to realize that this is now a float and they're doing floating point operations. It is. So it realizes that it does this type of thing. All right. I like this this hello world that Odin uses to show the syntax of the program. It already shows a lot of important features, and also it gives me a goal to work towards in my own language to support the features that are used to run this, right? So this can be my my hello world for my language. Write something that is able to do this. Okay, what it has function declarations, function calling. Though you don't necessarily have to have it. For example, Odin doesn't have it. It just has a function declaration for main, which you don't necessarily have to have. Swift, I could have done this without a function declaration. I could have just done it directly here, but I'm personally choosing to use a function declaration in all of them to include these types of things, right? To know what a function declaration looks like, because when you write in a language, you write a lot of functions. To know what a lambda looks like, I chose to do it that way. To know what a return looks like, should I make it do both? Actually. Well, this should be a let. Let ret, and then return ret. Ah, you don't like that? Oh, wait. You don't actually return. Imagine having block in code and then refactoring some function to have a callback as last argument. Boom, if you're lucky, you will only have very strange errors at compilation. Oh, with my current compiler, 100%. That's going to be difficult as fuck to read. But I just like the way that Swift does it. I think it didn't even have it in Swift 1. They added it later on. Alright, what's your problem? Cannot convert value of type int. Okay, so actually, the type system is smart, but not that smart. So when this was inside of this, it was like, well, the argument of this one is a float, so this is a float. Well, no. This is a float. But now it resolves the type here. It doesn't have the information on that it should be a float, and so it isn't a float. But that helps me actually declare it explicitly as a float. If it was a little bit smarter, it could realize, hey, okay, this ret, I don't know its type. It could be an integer because they're using an int here and they're using math operations here. Could also be a float. Could also be a specific integer, a specific type, specific size, I mean. But it's been used as a return here and as a float here, so it must be a float. But it's not smart enough to do that. But there we have it. All right, so I'm expanding. At this point, I'm just doing busy work just to expand the kind of work that the language does. And to have as much syntax of my language as possible. To disable AI in Z, there's literally just you just search for AI in the settings. Disable AI, there you go. It's that simple. For instance, I'm not using any conditionals. And there's another thing that I like that Swift does, so I want to show that off too. And I'm using Swift as a language that I'm very familiar with, even though I've sometimes forgotten the syntax of it. Well, no, I think I've written all the syntax correctly. All the errors that I have gotten are separate from me forgetting the syntax, I think. Yeah, Steve. So I think I've remembered the syntax. I'm just a little bit rusty in the language. But either way, I've shown a switch statement. I might as well show an if statement, if possible, and definitely a guard statement. Because I want to integrate something similar in my language. A guard statement is an early return. This is where I might actually fail in remembering something. Yeah, I got it wrong, didn't I? Hmm? Oh, I didn't put a parenthesis here. That's the problem. Actually, hold on. I want to know how much memory these things are using. Wait, this takes a snapshot. Does it like 32 megabytes? You're telling me a static Reddit page uses like 50 and a code editor uses 30? God damn. Ugh. Anywho. If I now pass it an empty program, hello? Did you get stuck? I feel like it got stuck. What's going on? Oh. Oh, wait, hold on. I didn't realize the program is actually in here. Windows 2000 in the browser is only 40 megabytes. God damn. All right, so as we see, we have a guard, which is an early return, and it just tells me that the program cannot be empty. Right, so I can then put whatever I want in this program. And the result is 1. That resulted in 1. Browser text editors are heavy on resources. 40 megabytes is not that much compared to Reddit. Because if you go to Reddit, why is this the first thing oh, it's Taylor Swift. I thought it was something way worse. If you go to Reddit, 80 megabytes are being used by this shit. To be fair, there is a giant picture of Taylor Swift and a bunch of other pictures here. So let me find the text-only thread. Okay, so this is only text. $98 megabytes. More than when there was a picture. 3 times as much as the Swift editor. That's what I was referring to. Also, sorry for the Taylor Swift jump scare. With that being said, my program's 0, 1, 1, 2, 1 times 2 divided by 2 multiplied power. So yeah, it's literally 1. All right, let's get rid of that divide. 16, and then we can divide at the end. And that was, man got scared by Taylor Swift. Imagine if that was Nicki Minaj. Fair. Okay. So my program works. I was able to show off a guard statement. An if statement is not particularly interesting, but you know, it's just the opposite of a guard statement pretty much. Could have just done if, then without the else. And it's literally the same thing. Just, I like that Swift integrates guard. Because it encourages early return, and I like early return. I don't like nesting all that much. Okay, so to show off some very basic features of the language, I feel like this is a pretty good goal for a program that you can write. Maybe I'll start refining it more as I write different languages, but it's a pretty useful starting point. And I feel like, yeah, it's helpful for showing the kind of syntax that I want to, or for seeing what syntax different languages use, and for seeing what I want to borrow from them. So from Swift, I think I definitely want to borrow this. Maybe not this right away anyway, but definitely the argument name in the function call is a thing that I think I want to have, because otherwise you could have a program that looks literally like this. Which, by the way, if you want to, you're still more than welcome to do in Swift. Just do it like that. But this, you look at this and you're like, what the fuck are we calculating? But if you have the name program, then you at the very least understand you're calculating some kind of program without having to look at what the function is actually doing. I feel like that makes it a lot easier to read. And for example, there's a lot of functions where like the last argument is a zero, is a false, for example, and you're just like, what's false? You have some functions in C like draw x, y, and then this. You can pretty clearly tell what's going on here. We're drawing to an x coordinate, y coordinate, this color, which is a hexadecimal value. That's pretty easy to understand, but let's face it. If there was a random false here at the end, you'd just be like, false what? Whereas instead, if it says like, overwrite false, color, there you can do it like this. Now, I do want to make the argument name kind of optional. And for that matter, I don't even want to rely on what Swift does with this symbol. I just want to make it completely optional on your end, whether you want to include it or not. I just want to make it nice to have, because again, it's not really useful here where x equals x, y equals y, color equals a very obvious color. But this false, yeah, you don't want that. So let's see if the compiler is able to do that right now. Obviously, it's going to fail with a line 14, column 45. So here probably. Yep. That's where the error is. During the week, I will most likely try to make my parser see if it can output a little bit of what exactly went wrong. It already knows it. I got this far in parsing, and then I failed. You could easily tell me where you failed. Expected comma or expected parenthesis found this. You could. But I think that would require a little bit of look ahead. But it would be nice to have. So I'll see what I can do during the week. See if I can have that. It's not a thing for doing right now. What I want to do is I want to make these optional argument names, which are going to be completely ignored by pretty much everything. Maybe they shouldn't be fully ignored because there is a chance that you will actually like forget them or like get them wrong. So it should check against the function definition to see if the name is correct, but starting point is going to be an identifier. Wait, hold on. I can actually create new rules now. So argname is actually a identifier with a colon, and argname is optional. It still fails, right? It didn't modify the rules. That's kind of not a good sign. Did you not make rules? No, it didn't. Undefined reference to C linked list push. Oh, wait, hold on. I need to update my library. All right, there we go. Var false does not exist. Oh, wait, it doesn't know what a false is. There's no definition of false anywhere, so it thinks that's a variable. And it's like, wait, where did you declare this, bro? All right, there, it seems to have worked. So let's see, for my declaration of... No, it's actually not found anywhere. Bum, 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 bum. Output.c. There you go. It's completely irrelevant, but it is nice to have. I can put those names there. They're not being checked for anything. They're just there if you want to have that kind of thing in your function call to remind yourself of what it means. It makes code a little bit more explicit. So, cool thing to have. Cool thing to have. What about... what other feature can I steal from Swift? Like, again, I have a little bit of a notepad here where I can see the syntax of the language that I want to have. Enforcing argument names in headers is very much a thing already, even though they are not checked against the function definition. We are also not checking that the function exists in the first place, so it's not really much. There is defer, but I don't have that right now, obviously. I consider doing an error return or e-return, I guess. Well, I don't even have returns, so what am I talking about? Let me get to that when I get to that. Yeah, that's pretty much all I got in terms of rules that I can include right now. Maybe I should expand my expressions a little bit because there's not a whole lot that you can have as an expression right now. Well, I don't know. A function call is an expression that you can have. Not sure if that's right to tag it as expression. Let's see. I am now technically able to do syntax error. So I'm not able to do. I should be able to do 2, 3, 4, 5. Yep. A syntax error is kind of unexpected. Maybe I would have expected it to fail in the code generation, and I would have expected it to fail in the other thing. But I wasn't expecting it to fail in the here as a code generation. Do I need to just put it at the end maybe? I feel like the order of these rules kind of is important. No, it still fails. On line 22. I mean, on line 10, column 22. 22. Here. Yeah. Wait. Yeah, as an expression, it should be there. With blocks passed as callbacks, Swift has very strange function overloading. Oh yeah, it gets quite weird. These features were done with duct tape a little bit. And it relies a lot on it. Like a lot. The entirety of Swift UI is built off of this. I don't know how it's done internally on the compiler side, but like, I mean, it works pretty well. It just like kind of prevents you from doing certain things. But yeah, like for example, if this ended with 2 closures that look exactly the same, you cannot do this. You would have to specify which one you're using. But yeah, the entirety of Swift UI, their entire UI framework is built off of this. And honestly, I like it quite a lot. Because I can have HStack, Boom. Opens here, closes here. Image doesn't use any. VStack. Boom. That syntax alone can make Swift quite declarative in a similar way to what I'm trying to do here. Here's just not in the function call, but in the function declaration. I'm trying to make it look declarative. They're trying to do it in the function call. But honestly, I think it's quite good. Again, I don't know how it's implemented in the actual compiler. Okay, but you are failing. You need to tell me why. And again, tell me why. Well, first off, did I use the right thing? Function call, identifier, argument, left parenthesis, right parenthesis, semicolon. Oh, semicolon. Makes you wonder. Do I just need to put 2 in? No? Okay. I was kind of worried. But no, it actually fails here, which means that, yeah, it just doesn't realize that this is a function call. Okay, well, let's isolate it. And then make the parser verbose. It can tell me exactly what is going on. Here. Okay, statement subrule function declaration. No. Statement subrule declaration. Yes. Declaration expression. Yes. It doesn't have a constant. It matches where option 1. Okay, so option 0 fails because it's not a constant. Option 1 succeeds here because it has an identifier. But it fails in the next one because it doesn't find an operator. It finds a parenthesis instead. Next one fails. Oh, I see. There's just identifier, so that succeeds and the rest fails. So this needs to be put here probably. And it still seems to fail, but I feel like it got further. Oh no, it worked. Okay, it worked. Yeah, so the rule order is important. What I'm surprised about is that it cannot go here. I would have felt it would have gone fine here, for example. Here it succeeds. What changed? It doesn't work here. Now it does. But... okay, it's the semicolon thing. But the token works if you have 2 semicolons, which is kind of required right now. And yeah, I output some weird spaces here and the 2 semicolons, but it works. Okay. Well, it needs a little bit of fine-tuning, but we can put it there. All right, I feel like I should fine-tune the double semicolon thing. Where does a semicolon actually need to go? The semicolon doesn't need to go in each rule, it needs to go in the statement. Or even in the block? No, because not all statements can have semicolons. A function declaration has it. A declaration has it. No, a function declaration doesn't have it. Sorry, that's not a function call. That's a function declaration. An assignment has it. A function call has it, but only when it's here. A conditional doesn't. A jump does. A label does not. Right, so we can get rid of it from here and here. And okay. Now it actually manages to compile without the double semicolon. Even though it still generates the double semicolon. Which is a code generation issue, not a code parsing issue, but cool. That was the thing that was kind of weighing on me a little bit there. Can I now make semicolons optional? Makes you wonder. I know this is controversial. People don't like it when I do this. But you're not the ones writing the language now, are you? The problem is I make my language new line sensitive, and then I have to be kind of careful when new line becomes a token, semicolon new line, which is what you're doing like here, for example, semicolon new line isn't parsed correctly. So I should be able to include the rule of semicolon or new line, but not actually implement it. All right. If I'm not mistaken, I did include the option for parsing new lines, but again, it will break if I do this. Yeah. Because it's either a semicolon or a new line. But for example, this new line is not expected, which is why it tells me that on line 21, which is here, but really it's here, why is there a new line I'm not expecting? So I should make my parser kind of be like, hey, if you encounter a new line that you don't expect, that's okay. Don't worry about it. If you encounter a new line that you do expect, that's also okay. So I kind of need to make it work that way. But I don't know how difficult it would be. Let me see if I can quickly do it. Here's where it fails to match the token. Here's where it's being called. If token kind... No. Yeah, it's not trivial. So I'll get to it eventually, but right now is really not the time for it. Essentially just ignore new lines that you don't require, but look at the ones that you do. But still, I'm able to do this with the right rules. And if I formatted my code to only have the necessary new lines, then I would be able to make it work. But it's really not necessary and whatever. All right, what other kind of syntax do we need to have in this language? Expressions inside of parentheses is a big one. And also dot. I'm not doing arrow like C does. I'm only doing dot. I think that's reasonable. I think it shouldn't really matter if something is a pointer or not. But maybe I'm hiding too much complexity. I should give it to the... I don't know. I haven't really decided for that. if I want to have things like star and then pointer access, or if I want to hide that complexity yet. So I'm not going to consider them. I could technically integrate them into the language and then remove them, but that's kind of boring. Or I could integrate them into the language and keep them, because I want my language to be an intersection of C. I don't know. Okay, an expression could also go inside of parentheses. Can it actually just go like this? Can it handle this? Rule-wise, it did. Code-wise, it seems to have. And output-wise, it didn't. Because it considers this to be an expression, maybe? Now, it finds all of these. So what's going on with only outputting this? I keep forgetting that if you scroll on this bar, you go to the next desktop. Kind of forgot that this is a thing. I mean, all of these symbols are actually being detected, but they're not being printed. It's just a problem of my... Yeah, how far back does this go? Is the question. When did it break? Oh, it's quite a long time ago. Shit. Is it when I added the semicolon rule? Yeah, that's what broke it. Wonder why. Kind of unexpected that it does that, but I have to refine that whole like semicolon new line thing anyway, so I'll definitely get back to it. Lparen expression, that is an expression, rparen. Okay, is our code the same? Is Uable? The output probably won't be super correct. Yeah. It is correct in the sense that it is able to handle parentheses for expressions. It is not correct in the sense that it doesn't conserve the parentheses, and so that will lead to confusion if I do something like 1 plus 0 minus 2, which is technically now valid syntax. This will output it as just 1 plus 0 minus 2, which is missing the parentheses. So again, the syntactic analyzer can handle these things. The code generator cannot, because the code generator is itself C, technically. It knows the code that it's writing in C, and it doesn't know that the parentheses are there, so it doesn't even understand what it is doing. The compiler is for the language that we're designing right now. It's not super defined yet. So kind of the compiler is actually experimental to just handle iteration like that. 1 minus 0 minus 2. Yeah, that's a better example. I put a plus. But if I put a minus, then yeah, it's what it says in chat. Which one is it supposed to be? It's supposed to be this operation first, then this one. But when you look at the code that's being generated, it doesn't know that. So that fails. But again, it's a code generation problem. The code actually understands what's happening. The code generator doesn't. Can we quickly update it to handle these types of thing? There's also the fact that the code generator doesn't understand within which context it is creating something. So for example, when it outputs a function call, it outputs it with a semicolon at the end. It just so happens that since now function calls are also expressions, shouldn't I also output it without a semicolon? Like, it doesn't know that. So it doesn't know where a semicolon goes and where it doesn't. So it generates a double semicolon here, which is technically not wrong. It's just unnecessary. The question is, can we make it handle the parentheses in a quick way? Again, everything that I'm doing right now is if it can handle it quickly, I can make this fix quickly, then I'll do it. If not, we'll just continue iterating over the syntax and I'll fix these things later. Okay, the C code generateur. No, it's actually not the generator. It's the general for the expression. Here it is. The parentheses are kind of ignored. So you should know them. I could do something really stupid. For the sake of it, I want to do something really stupid. When you emit an expression, just put a parenthesis at the beginning. You put a parenthesis at the end, and it's gonna be crazy, but it's technically gonna be correct. It just generates a bunch of parentheses around everything. And now this is no longer correct. Would you look at that? Would you look at that? It's technically correct until you get to the semicolon thingy. It's technically valid. It just isn't right. But, you know, it is a patch, which I'm not including. All right, let's keep iterating over this, and we'll get to it later. We'll get to it when we get to it. Or there is another way. No, we're good. We're good. Okay. What else do I need to do? What I need to do really is expand what this expression really means. Because there can be a mathematical expression, a logical expression, or a single expression. Not sure about the names of these, right? But essentially, this is its own expression. If I do something particularly complex, like I do token, kind, well, no, not really. But let's say that I do parser, scan, buffer, 0. This is all one expression. Whereas if I do This, it's two different things because it's a mathematical operation. So I should separate those two because there are places there are places in which you can have single expressions and places in which you cannot. You cannot chain them together. Like if I just keep using one node, then it's kind of going to be a mess. So I'm going to fix that. I'm going to see how I can fix that, then expand the language more. But there is an ad break coming, so I'll be back in 3 minutes. Okay, we're back. And here's a little inspiration if you ever feel lazy. You're not as lazy as you think you are. What do I mean by that? There's currently 14 people watching on both YouTube and Twitch. Oh. And that thing just moved. Most of you don't even know that there's a dog under that. Because I put him under there at the beginning of the stream when there were a lot fewer people. And he hadn't moved until now. I feel like he knew that I was gonna lift the blanket, so he did it for me. It's like, if I'm gonna do it, it's gonna happen on my terms. Anyway, yeah. If you ever feel lazy, he hadn't moved in literally 3 hours. And now he's immediately back to licking himself. Which is why I put the blanket on him in the first place. Okay. Well, thank you for joining us, Jester. What's up? Okay. As I was saying before the ad break, in a language, you have expressions that are kind of separate from each other and expressions that are joined. So, this is one joined expression. This here, which is just a nested function call, so this is a function call, this is a function call, are joined, whereas this is kind of separated in the sense that it has a left side and a right side, and it has an operand between the two. Are the only kind of separate expressions mathematical ones and logical ones, which to me they both use this operator token. Not sure. I think so. I think so. So yeah, we can make some mathematical expressions, which are just these. Damn. I just gentrified expression. When this rule started, it was literally just these two. Then I started adding these two. Then I added this, then I added this, then I moved these two out. That's gentrification if I've ever seen it. And it fails on line 11 at 14. Why does it fail? Oh, well, the parentheses thing. Well, hold on. I removed it, but like, it should still be a part of it. There we go. And it, I kept the. No, you shouldn't output all these parentheses. What's going on? Oh, they're gone. No, they're not gone. Hold on. Discard these changes. Is there a way to discard the changes but keep the file open? I'm honestly not sure. But anyway, can I pin this file, by the way? Yes. So it's always here on the top. I should start using these types of things a little bit more. This one also needs to be pinned because we're constantly going over them. And the street cred one, where you at? Why is it not here? Bro, just... Where is the file in the tab? Am I supposed to find it from these? Yeah, it was. Alright, so these three should always be open because they're the ones that we're working with. Here we define the code. Here we define the language. Here we see the output. And you can see the compiler is currently a little bit limited, but it is great for iterating and deciding the syntax of a language because I can just do it in a single... It's actually 2 commands being run. And currently, in order to change the rules of the language, you need to recompile the compiler. But what's really changing is an array. So do you really need to recompile the entire compiler? Not really. I could lift that limitation eventually. And then you might be able to just run the compiler and iterate over your language without recompiling anything. So literally just one command. But that's not something I'm super interested in right now because recompiling the compiler takes like a few milliseconds. You don't even notice it. I'm literally deleting the old file, recompiling the rules, recompiling the compiler, and running the new compiler. And to us, it looks mostly instant. So it's fine. Either way, what was the last change I made? God, I don't even remember. Well, yeah, I added the mathematical expressions thing. Which is technically a little bit more correct. And for that matter, I could do this, right, which still works. Still outputs in the same manner. It just, every time there's more nesting, there's more and more spaces being created in the code generator. You can literally see as everything gets further and further apart. Like I said, compiler is not ready yet, but it's actually doing quite well. But I feel like some of these, well, really just this one. The function call is technically an expression, but there are other types of expressions that you can have that aren't necessarily assignments, right? Left hand, like what exactly though? Function call, declaration, if statement, else. I need to add else, by the way, and else if too. While loops, could add those. Return, probably need to add that. And then all the other forms of return that I've mentioned, like error return and... Oh, I wanted to do something with auto return. I'm not sure how I want to do it. But essentially, there are some functions that you write like this. And here you do something, right, with that A. Like, well, let's say that it takes an argument B. If B is bigger than 0, then just to make my code valid. I don't know what the fuck this function is supposed to do, right? But the point of it is, I just do a bunch of complex operations over A, and then I return A. I create A at the beginning of the function, and I return A at the end of the function, and I do a bunch of complex stuff on A. So I was thinking, could I mark it somehow? I don't like that syntax, but that's just, you know, to show. There's another thing that I could do is like, this one could return A here. Yeah, I'm starting to see why this could be a problem. Early return is not really possible. But if you don't have early return, anyway, let's say that my function looks like this, essentially. I'm never good at writing examples that are simple, but like... multiply by itself, whatever. Something like this, where depending on which one of these paths you go down, A takes on a different value, but it always ends up as the returned value. So marking it somehow as the one that gets returned, and then doing that. The problem with this being, yeah, never mind, this is stupid. Because how do you know to return here, here, and here? Whereas, for example, here maybe you want to return, here you want to return, But here you want to run this before you return. So yeah, you don't know how to return, so that's a stupid idea. All right, perfect. Stupid or just kind of redundant, because if you don't have early return, then you can just do this instead of putting it here. But yeah, I don't think there's much use to something like that. So good thing that I noticed that it's not important. Anyway, these kinds of things, these kinds of expressions could be on the left side. Which my system currently does not handle. But whatever. Let's do some chaining. How does chaining look? It uses the periods, so it uses dot. Is that what it's called? I'm not sure. I guess we'll see. It is called dot. The problem is what goes on each side. You can put a function call there. You can put an array access there. You can put an identifier there. What else can you put there? Gets a little complex then. Either way. You can have identifier dot expression. But not all expressions are valid here. A function call is valid. This is not. This is not. None of these are. So either a function call or another identifier, I guess. That's because I currently don't support what are those called? Arrays. I don't really review code, sorry. Let me see then. I could have x equals y. Nope, I don't have arrays. No, that fails. On line 16, on column 18, the dot. Because I didn't actually include it now, did I? It still fails. I guess I'm gonna use the programming language to code in it. I'm not sure like I have any particular goals for it. Bro, can you stop doing that? Okay, tell me why it failed. We start here. Block statement. Function declaration, that's not the one. Declaration, that's not the one. Assignment, that is the one. You parse x equals, so it is an assignment. Then you try to parse it as an expression, try to parse it as a function call. It's not. It is a function call though. No, it's a chained one. It's not math. Why does it end there? This is weird. Tries to match it as math. Failed to match token const. That makes sense. Failed to match token operator. That also makes sense. Failed to match token const. Math 3. Parses token identifier. Oh, so it succeeds because of that. Okay, I understand what the problem is. View. Math should really only go here at the very end because it can just match an identifier by itself and then the rest don't match. Is the OS done? Kind of. I'm still working on its stability and more stuff that I wanted to have, but it's doing pretty well. Actually, I was thinking, now that the compiler handles writing C code, it actually outputs something, let's call it useful, then tomorrow I might start looking into the next step for the operating system, which is distributing it. So being able to communicate with other machines. And I have a vague idea of it. Let's say I talked about it more at the end of the stream when I decide what I'm going to do tomorrow, because yeah, I'm mostly focusing on the compiler on my streams now. I stream 4 times a day, Jesus. I stream 4 times a week, and 3 of them are dedicated to the compiler, but 1 of them is still dedicated to the operating system. Last week, I wasn't sure what to work on. I was working a lot on stability and bug fixing and whatnot, so I skipped it. But this week, I do want to do what I'm gonna say later. So yeah, we're still, it's still happening. It's still a thing. It's in a pretty good place right now. Okay, y.run. Ugh. Yeah, the order of these is important. Yeah, but var x does not exist. Mi hermano en Cristo, what are you talking about? Time is up here. 6:20. What do you mean var x doesn't... Oh, wait, no, hold on. I deleted the rest of the code, so yes, var x doesn't actually exist. You've got a point. Okay. Alright. The parser has not broken. Do you know how major this is? It's pretty major. Actually, the only bugs that I have encountered in the parser so far, it has limitations, granted. Let's be clear. Again, when there's an error, it doesn't tell you what the error is. It just tells you, like, it's here. And most of the times, it's not even super accurate. But it doesn't know what the error is. So I have to step through this whole thing, which, by the way, looks like this. It's just indented, so it gets a little weird, to understand what is going on. So yes, it has limitations, but bug-wise, I've only found bugs when it comes to backtracking, and I've fixed them by just rethinking the backtracking logic a little bit. I find that when you find a bug in a system a lot, you need to kind of reconsider the entire system, because there's something fundamentally wrong with it. Instead of patching, it's better to just like, all right, let me start over. It doesn't necessarily mean deleting all your code for it. It just means like, let me reconsider the logic for the system from the beginning, and then I'll realize and compare that to what I've done, and then I'll find a bunch of bugs, a bunch of issues that I've made. A bunch of, yeah, like mistakes that I've made, I mean. If you don't mind me asking, how do you do all these from scratch? There are like very few resources online, and LLMs give unstable responses. We're learning these kind of stuff. Well, the way that I do it requires quite a lot of compiler experience. Jesus. Quite a lot of coding experience. knowing the basics is very important. And then, what was it, last week? I think people on Twitch were who are more familiar with building compilers were telling me, okay, these are the limitations that your compiler has. These are the things that you won't be able to do. And they're kind of things that I already kind of knew. For example, the one with the error messages. My compiler doesn't really know how to give you a proper error message. Because the way that I built it is kind of very naive-ish. I know what I'm doing. It's not the first compiler I build. But, and I am aware of its limitations, and I may even think of ways of getting over those limitations. But the way that I'm able to build these things is by just thinking about them not in terms of like, how is this normally done, but what am I trying to accomplish, and then how can I accomplish that? Which requires quite a lot of programming knowledge, but you'll see that I barely look at resources. I barely look at documentation. I barely look at existing examples. There are a bunch of resources for compiler generation that have been shared to me on Discord. And I have them there in case I ever need them, but I've looked at them like very surface level, just like, oh, this is what they're talking about. Okay, cool. But pretty much that's my approach. What am I trying to do? How can I do it? Break it down into small enough steps. And you may not come up with the most smart implementation. You may be reinventing the wheel, but you're inventing the wheel still. So that's cool. And you can always improve on it later. But yeah, books are also one that I personally don't use, but yeah, you can. And keep in mind, everything that I said applied to a lot of things that I've built, like the compiler itself, the window manager when I built that like a couple weeks ago. I know my windowing system because I built the windowing system. I want my window manager to just put a window on the screen, full screen, when I press a keystroke, when I press a shortcut. I know how the shortcut system works because I built it. I can easily do that, combine the knowledge of the thing that I built, the thing that I built, put them together. That's simple. How does a window manager handle efficiency? I have no idea. How do I optimize my window manager? I have no idea. How do I tile my windows? How do I resize windows when I bring a new one in so that it takes full screen, then half screen, then half of half, or half of half? I haven't done any of that stuff because I don't need it. I will add it. If I really need to, I'll look at what algorithms are used for this, but if not, I'll just think like, this is the problem that I have, and just think about it logically and see how that goes. I think this does require quite a lot of programming knowledge. And when you do have a lot of programming knowledge, a little bit of optimization comes in as well. You'll be like, okay, I could use a linked list for this, but a linked list can be a little bit inefficient. Whereas I know exactly how many items I'm going to have. I can just use an array. That kind of thing. It's a very simple example, but you understand. That kind of knowledge you have, but then, yeah, specializing your knowledge is a thing that comes as you build something. So I wouldn't be able to do the same features of an operating system if I started doing them in Linux. I'd know how to do them in my system because I'm very familiar with my system. And I wouldn't have been able to do them in May because I started the system in April. That was, first off, it didn't have half the features that it has today. And also, I didn't have the knowledge and the familiarity with it that I have today. So experience is the main way that I'm able to do these things without looking too much at documentation and whatnot. But then breaking the problems down. It just so happens that I kind of can break bigger problems down without needing to look at reference too much. You're fed up with AI engineering? I would be too, to be honest. No, I mean, the AI, like engineering side of AI is interesting, let's face it. It is interesting. Hell, at some point or another, I've built a neural network. C++ though. Never been particularly interested in Python. I've used it for a couple scripts here and there, but I always end up relying on a more reliable system eventually. And why can I not deselect this? This is like flashbanging me. Maybe flashbanging is not a word that I want to use ever again. Okay. Anyway, I managed to get it, right? I think. Why is this so messed up now? I managed to get... Ooh, not quite. Not quite. Oh wait, chain doesn't know how to generate any rules. So that's kind of a problem. I think code generation is starting to break down a little bit because it doesn't have half the features that I'm adding to the system. Keep in mind, I now need to maintain 2 languages. My compiler's version of C and my own version of my language. My own version of my language I can quickly iterate over using the rule parser and rule gen. The compiler's version of C is entirely hard-coded using a bunch of types that represent each type of behavior. So yeah, this happens. You have y space blah, 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 semicolon semicolon run when it's supposed to be y dot run, because it doesn't understand dot. It doesn't know what this is. I haven't added the concept of chaining 2 things together like that to the C of my compiler, but I have added it to my language, to cred. So now I need to maintain both. This AI bubble is gonna burst, and I'm a CS grad, so I kind of liked my OS course back in uni. So yeah, let's see how my journey goes. Let's face it, I feel like basics are the best way to go. For example, if you want to learn a programming language, which one do you want to learn? Do you want to learn Swift and make iOS applications? Do you want to learn Kotlin and make Java applications? Do you want to learn JavaScript and make web applications? Do you want to learn C# and make Unity applications or Windows applications? Don't do that one. Don't do that one. But yeah, do you want to learn those? Or maybe start with a low-level language like C. It will teach you the very basics. I was talking yesterday about how few abstractions C has, which is also why I chose it as, first off, the language that I write the most on stream anyway. And for an operating system and for a compiler. And also why I chose it as the target language for the compiler. It compiles to C. This is the reason why. Because C has very few abstractions. Very few abstractions means you have to be a lot more intentional about the code that you're writing. And you can and will make it do things that you don't want to. And it will crash and it will fail. But you learn the basics with it. You learn memory management. You learn what a pointer is. You learn all the basic concepts of programming. So I started learning C, actually. I started with C, then moved to C++, then C#, and a bunch of others here and there. Swift as well. Well, actually Objective-C and then Swift as a whole thing. Let's forget that Objective-C ever existed and just say Swift, yeah? But I'm glad that I started with C because it taught me a lot of these very slightly more advanced but still very important concepts. You could go your whole life writing C# without understanding what a pointer is, but then you move to another language and you're like, it does things slightly different. You don't fully understand what it's doing. Whereas if you start in C and you understand the very basics, everything else is just an abstraction on top of that. I mean, if you do assembly, even more so, everything else is an abstraction on top of that. I feel like assembly is very verbose, whereas C is an abstraction over assembly. Hey, Gopher. Which is nice. It's still low level enough that you still understand very basic concepts of how computers work, but its syntax is very similar to a lot of other languages because you also have to keep in mind in the beginning there was C, and then Ken Thompson said let there be C++, and so we had C++, and then someone else said Microsoft said let there be C#. C++ is not shitty enough, let's make something even worse because we are Microsoft. So they made C#, and then somebody else said, hey, you know what? Let's make it even more boring and create Java. And then somebody said, accessing memory sounds scary. Let's make Rust. All right, just being mean at this point, but yeah. C was at the very, very big. Well, not really at the beginning. There were previous languages before that, but like a language that is used everywhere. Every language can communicate with C. Ish. Linux is built entirely in C. Mac probably has a bunch of C in it, and I wouldn't be surprised if Windows had a bunch of C in it. IDK, but I'm assuming. Learn C, C++, and then you get into roles at Qualcomm, ARM, and something like that. Also, yes. If you want to stay at low level, yes, 100%. But I feel like C and C++ are great for starting out. C++, if you also want to learn a language that is object-oriented. But C, in all of its basicness, will teach you a lot about how the computer actually works, sometimes without you even realizing it. And so you will learn a lot about how all other programming languages work because, well, they all run on computers, pretty much. Zig, I like Zig. I was talking about Zig a little bit earlier. We are going to check out Rust at some point. We're going to write the same thing that I wrote today in Swift in Rust as well, eventually. Not in a hurry, though. So we're going to check out all of these at some point or another. Hoping that they all have playgrounds online that I don't have to download anything, because fuck that. But yeah. At the end of the day, syntax is different in different languages. Paradigms are different in different languages. But at the end of the day, they all work on the same computers. So if you learn a language that is low level enough, you will understand how they work. Maybe you won't understand everything immediately. It's not like I can step into Rust and immediately write a compiler in Rust if I wanted to. I probably couldn't do that. Then you would see me look at documentation a whole bunch. You saw me doing that in Zig. I didn't have to do it in Swift because I'm familiar with Swift. I was a little rusty on the syntax, but I actually got everything correct. So I didn't have to look anything up. But, for example, I wouldn't have been able to know that Swift relies so much on functional programming like this if I didn't already know that. So maybe you won't learn that about the specific language, but you'll still understand what's going on behind the hood, and that's always useful. And even then, you can probably write the similar code to what you use in C in other languages. I didn't need to use reduce. I could have written this in a very traditional C-like way in Swift. If I didn't know that this is how you do it in Swift in a, you know, elegant way. I like Swift as a language, but I don't want to be in that ecosystem at all. I like the ecosystem. Yeah, unwrapped variables, another thing that C technically won't teach you. It's again, I guess, a paradigm of newer languages. And the thing is that what happened with C is probably never going to happen again with any other programming language. We don't have a base. We have a baseline programming language, which is C. We don't have a baseline memory safe programming language. You have Swift, you have Rust, you have some others I don't know about. There's a bunch of languages that are memory safe, but they don't have a common layer. They didn't all evolve from the first one of them. Whereas C++, C#, Java all evolved from C. Swift evolved from Objective-C, which evolved from C. Kotlin evolved from Java, which evolved from C. And Rust, they must have learned a little something from C. So in a way, probably got inspired either by C or by a language that was inspired by C. So you have this common baseline. So even though you have to learn new stuff to learn a new language, you already have the basics. But memory safe languages don't have that. So what happened with C is never going to happen again, most likely. We won't have another baseline language. As much as people love to think that, oh, we can just replace C with Rust. No, that's just not going to happen because C is already there. Your company forces you to use VS Code? Jesus. COBOL or OCaml? OCaml is one that I also want to look at because I heard that the first Rust compiler was built in C. In OCaml, I mean. Zozing said that in his YouTube video from today. So I saw that. I got interested in what even is that. COBOL? It's pretty much only used in banks nowadays. Maybe governments? I don't know. Don't bother. I mean, shit, you can probably be paid a lot of money if you do COBOL. But like, you'll be writing COBOL, bro. Would you really want to do that? Would you really want to work at a bank? Would you really want to work for a government? Not just a government, but your government? Because let's face it, you're not going to go work for the government of Indonesia if you're from the UK. Probably, I mean, maybe you can. Pretty sure the Spanish government actually requires you to have a Spanish citizenship. So, not that one, I guess. But maybe I made that up, I don't know. I can't say I've ever looked into getting a government job. But yeah, I guess COBOL is useful, but it's just like, do we really want to do that to ourselves? Is it worth it? You got money and job stability, but is it really worth it? Wait, you write COBOL? Since you're saying that you don't work for a government, I'm assuming you're saying that you do write COBOL. Can I ask what industry if that's the case? Not the specific job, but just the industry. Okay, I'm going to try to add arrays in the meantime. Backend engineer with your own startup? Wait, so do you write COBOL? If so, why? I mean, I've never written COBOL. Maybe it's like amazing and I just don't know about it. I know it's English-like, I know that. It's kind of weird. What's all this yapping with zero code examples, bro? Here it is. Add 1 to x, add 1ab to x rounded, yz rounded. I have to say I like that. It is more English-like, which is nice, but no. Still, I would rather you do this than talk to an LLM. So, on size error, display error? Holy shit. Is Cobol good and I just... Has it just been gate kept and I've just blindly ignored it when really it's just been the goat the whole time? Is Cobol good? Have I been making a mistake? Should we all just be writing Cobol? This is pretty cool. On size error. I don't write Cobol. Oh, okay. You were curious about the language because it's used in ATM machines. Yeah. It's used, I don't know about ATM machines. I do know that banks use it. From what I've heard, for Spain anyway, is that obviously banks probably have to communicate with some government services which require you to write COBOL. So even if a new bank comes out, like fully new infrastructure from zero, ground up infrastructure, they will still need COBOL. Something like that. Maybe not even like Spanish government, more so like international banking type of thing. So you require COBOL here or there at some point, something like that. But I don't know. And about ATMs specifically, I definitely don't know. I'm not expecting there to be a whole lot of write-ups for that type of knowledge. I do know it's heavily used in banking, but the details of it, I'm fuzzy on or I know nothing about. Okay, I said I was gonna add, not parentheses, arrays. So I guess I'm gonna add a variable. Type, which can be an identifier var, or it can be an identifier followed by L bracket, followed by math, followed by your bracket. Any other kinds? I'm gonna leave it at that. Whoops. Okay. So this would actually be a variable. This would be a variable with var. My most hated language is Java. Somebody asked me the other day, like, what projects should I do in Java to learn the language? And I was just like, look, you can make a Minecraft mod or the most boring program you could ever imagine. I even looked it up, and all the like suggestions were like, make a management software for a library, make a management software for a university, make management software for a store, make make accounting software for... It was just like, oh my god. Is this language used for anything good besides Minecraft? Maybe Hytale? No, Hytale? I looked this up the other day and I already forgot. Hytale is C. Oh, Java for server-side modding. Client was initially C Sharp. It's been rewritten in C++, but they went back to the original, I believe. So this is probably C Sharp. Right? It's a whole mess with Hytale. But, yeah. I guess it uses a little bit of Java. Then again, they started with... it's a spiritual successor to Minecraft, so it kind of makes sense. I love how I'm writing the most unhinged code here. I'm not even trying to make it make sense. Like, this is an integer. Why am I accessing it with an array? Oop. Line 12. 17. Yeah, you can technically just have a variable. There we go. Many companies still maintain their own Java. Yeah, there's a job market. It's just that like everything that we saw was so boring. All right, I'm pretty sure, yeah, this just results in this because it's kind of dumb. Also, I forgot to put var here. So it doesn't output that. It still doesn't. Kind of unexpected, to be completely honest with you. I expected you to be able to parse that. Then again, you don't know what a var is. So you don't know how to parse this. Is that it? What if I make it an expression? Do you know how to parse that? Yeah, but not valid. So we'll keep it as var. Okay. Again, I have to maintain two languages. So let me start with one and then the other one. Right now, I'm just adding some very basic stuff that you would need if you want to have some sort of you know, basic features. Array indexing is one of them. Parentheses, functions in different places. My main goal right now is to add these things and then, you know, experiment with the language a little bit. We added, yesterday I added optional void returns, optional arguments. I added argument names in function calls. We have optional parentheses in if statements. I'm probably gonna get rid of the goto because goto makes program flow quite complex to understand, to be honest. And if I'm not mistaken, I've actually managed to get rid of, not even to get rid of, to never include any gotos in any of my actual code. Even in the operating system, which is not trivial, I have to say. Long hair does get messy. I pretty much had to learn to at least trim it myself, because it's a little bit unsustainable to have to constantly get it fixed. But this is actually, I've wanted to grow my hair out, and I always reached a point in which I was like, I'm cutting it off. But this is the first time that I've actually been able to do it. No results to go to. So goto can make the program a little bit like harder to understand, harder to read, because it's not a function, because when you're calling a function, like I'm doing here, object function, that just means go inside of where this function is declared, which is actually a function pointer. Already a little bit complex-ish, but hey, not half bad. Go to wherever this function points to, execute this code, and then you come back here and you finish executing this function. A goto doesn't come back here, so it jumps all over the place, which is why actually I called it a jump. It's better to avoid them if you want to make your code kind of like readable, more readable. Sometimes it is useful. For example, in the operating system, at the very beginning of its execution, I have to turn on the MMU, which is the memory protection unit. And what it does is it just enforces that you cannot access memory that I don't explicitly allow you to access, essentially. And even I don't access memory that is unmapped. But one useful thing that you can do is you have an address that you want to access, like this, for example. You can add FFFF to the very beginning of it, like that. Don't count the number of characters here. It's super wrong. But yeah, you can add FFFF to the beginning of it. And the MMU checks a different set of translations, because it also like handles virtual memory. So it translates a virtual address to a physical address. And it uses tables to do that. So normally it uses one set of tables. But if you use that FFFF, it uses a different set of tables. And I have the kernel mapped there. When you turn it on, however, you have a function in which you turn it on. And then you actually turn it on. And now when you return, you don't want to return to where you were before. You want to return to where you were before with the FFFF. So it's very common to use a goto there and a label. And at first, I used it. But I ended up finding a way to not do that. You got hit with 3 ads? Jesus Christ. That's just default YouTube behavior, by the way. And I had to turn on ads because it was literally not recommending my channel anymore until I did that. You could literally look at my analytics graph and it's like, here's why I choose not to turn on ads. And here's when I choose to turn it on. So it's like, yeah, I kind of had to do that. But Jesus fucking Christ, YouTube. I'm not, can't speak for the alternative to that. I'm hoping you catch the drift without me having to speak on it though. Anywho, what was I even talking about? Yeah, go-tos are not great. I do want to generate go-tos, but I don't want to have them in my language. The thing is I don't have loops. Well, what does a for loop look like? It's the keyword for. It's a left parenthesis. It's a declaration. It's a semicolon. It's a condition. It's a semicolon. And it is an assignment. It's a right parenthesis, a left brace, a block scope optional, and a right brace. There are more modern ways of writing some of them, like automatically iterating through arrays and whatnot, but you kind of need your language to have a built-in arrays for that. Failed. Because I didn't I didn't include it, did I? I keep doing the same thing. No, that's not it though. What is your problem? On line 13, you say? How does this match what I said? Ah, shit. The semicolons. right? No. Identifier, operator, expression. All right, let me do one at a time. Let's say for and just the declaration. Close the parentheses. Can you parse that? Yes. And you parse it as a for loop, which means it's not going to appear here? Yes. Because it doesn't know what a for loop is, so it doesn't actually generate it. Okay, there's an add starting, but I'm just going to keep debugging this because it's not going to be super interesting. What about with a semicolon? Can you handle it with a semicolon? Oh, I need to put that in. Yes. Okay. What about the condition? With a semicolon, can you handle that? Condition looks exactly the same as this one, so it should be able to handle that with a semicolon, is it? It can handle that. And then, can you handle... Oh, what it cannot handle is the plus plus part. I didn't even consider that. That's what it cannot handle. Christ. Okay, it works, but of course... What in the name of fuck just happened? It broke down because it doesn't even know what the hell it's looking at. And you generate a for loop, it doesn't really know what a for loop is, and so it kind of breaks a little bit, but it works. This maintaining two languages thing is so annoying. But the good news about it is, I'm trying to write as many C-like features now, so that then I can just update the code generator with all the missing stuff, and then we should be most of the way there. Are there any other important types of loops? While, do while? That should be it. Do bracket, which is called brace, block scoop at our brace. While condition. Which means we technically have optional parentheses around the while condition. Also, you are a literal. You need to be very careful with that. While condition apprend le brace blocat scope brace. They're technically different in the way that they work. While could run 0 or more times. Do can run 1 and more times. So I'm separating them as different blocks for the time being. That's not good. That's not good. Also semicolon at the end of this. No. Semicolon at the end of this. Let's put it like that. No, well, I called it separator, but it didn't work, so... What is your problem, though? Do you kind of get stuck? Shit, this is the first time that the compiler actually fails on me. Hey, Jester. This is the first time that the compiler actually fails on me. Is there any real advantage to using Rust, or is it just a call thing? There's advantages. It's memory safe. But I have to say, do not ask this of the cult. Don't ask this question to someone who actually like glazes Rust, because they will tell you the stupidest things. Although, disclaimer on that opinion of mine, it comes from Twitter. And in general, Twitter users, especially those who pay for Twitter, I don't necessarily respect their intelligence or opinions in general on Rust or anything else. But still, was it good? Was dinner good? Just had dinner. Wants you guys to know. The usual, the same thing he's been eating for 5 years. And he loves it. Whoa, whoa. There. All right. Here he is. I've heard some ridiculous opinions on Rust. Like, this works. I saw someone say on Twitter the other day that, the other day is probably a while ago, that we should, it's a double one. It's a double feature, this one. Because I hate, well, I don't hate Rust. I hate Rust community, and I hate AI, and the AI community. And this one's a double feature for both. We should make LLMs write Rust exclusively, because if the code compiles, it's probably correct. This is the stupidest fucking opinion I've heard in 2026. It might have been from 2025. I honestly don't remember how long ago I read it. But like, either way, it's the stupidest opinion I've heard in a while. Okay, something about the while loop is just breaking everything. And the do while loop as well. What is it about you? Yeah, the Rust users tend to have this belief, I feel to a certain extent, that if you do it in Rust and it compiles, it works. But kind of, you know what? You can still have logic bugs. And if you have a logic bug, no amount of memory safety or type checking and type safety is going to make your language correct. That's an opinion that they stole from Haskell and other functional languages. Do people that do functional languages think that if it compiles, it runs and it works perfectly fine? It has no bugs? That's a stupid opinion in whatever language, but do they actually like think that? Okay, forgot. Does do while also full loop? Yes. Leaking memory is memory safe and A-OK in Rust. It is? That's a joke, right? The Haskell subreddit is full of this. Not a joke? I'm not gonna lie, when I was writing the rule parser yesterday and I was updating it to have optionals and whatnot, it's no longer, immediate like it was before. Essentially, encounter a rule, immediately output it. Now it actually like has to keep track of what it has. It's multiple like phases like that, and that means I have a bunch of arrays. And I was just like, in the actual compiler, whenever I have an array, it's hard coded. It's limited, but it's hard coded. But he's like pushing against me. Jesus Christ, Chester. When I was writing the rule parser, I was just like, I'm probably gonna rewrite all of this with this using the same architecture and the same components that I wrote the compiler in. So I don't care if I'm leaking memory like crazy. And yeah, it probably leaks a bunch of memory. I just never cared. Actually, no, probably it never cleans up its own memory. If the operating system does that. If it doesn't, that's the operating system's problem. And as an operating system programmer, I probably shouldn't be saying that. What is this syntax, bro? Y'all saw how elegant Swift is, right? Just want to remind you of that. I downloaded the code that I wrote. It does functional programming in such a simple way. This. It looks like normal code because it is. It just uses functional concepts. This is so weird to read. What am I looking at? Incredibly beautiful and simple, right? People still hiring COBOL devs? I was talking about that. I think banks and governments mostly, but yeah. Add Valgrind over it and add the appropriate free calls and stuff. See, the reason I didn't want to do it is I couldn't be bothered to do it. It's just like, yeah, let the operating system handle that one. If you don't clean up the memory of a process when the process ends, that's on you. Or on me if it's my operating system. But besides that, it's on you. Linus Torvalds or whoever the fuck maintains Microsoft. That's probably Copilot at this point. Not Microsoft, well, also Microsoft, but I meant Windows. And on Tim Apple. It's on those guys. Insurances also use COBOL. Yeah, I feel like there is a central system, financial system, global or government-wise, like local country-wise, that relies on COBOL, so they all have to rely on COBOL. That's what I was talking about before. But again, I'm fuzzy on the details of that. I am genuinely trying to understand this code, and I have no fucking clue what I'm looking at. I understand this. You start with an array of arrays, sort by, compare on length. Easy to understand. Okay. Okay. That one I understand. Is really reading like English. Actually, it is. I'll give you that. Yeah, it's reading like COBOL. Changes and additions are done by Java plug. Oh, it's just one L after another. Reading the article, I wonder how the implementation of isInfix off function would be. Then I searched and found a snippet beneath. EQA A bool. I have no idea what this means. Incredibly beautiful and simple? No. Isnfix needle haystack. Any is prefix needle tails haystack. What am I looking at? I understand this. I don't understand this. Hey, dreamer. We're kind of looking at programming languages at this point. I managed to break my compiler. Finally. It's been a long time coming, but it finally happened. I really wish the AI bubble would pop. Please, for the love of God. Not only do I want it to happen because of prices, I also want it to happen because it'd be so fucking funny. And I might as well make use of my Twitter account to just see what people have to say about it. It would be so funny. That guy's gonna have to maintain all the Rust code that he wrote that pretty much just works if the LLM wrote it. I have to say, this so many languages have interesting concepts and such ugly fucking syntax. And again, I'm biased towards Swift, but I feel like they did functional programming pretty well. You can even do kind of like really stupid stuff in Swift. Like you can do this. Well, stupid. Not super clear stuff, but like kinda clear, I guess. Like you should be able to understand. I don't know. Let me know if you understand what I'm doing here. I feel like it's not particularly complex. It's not working though. Oh, okay. There we go. Extraneous argument label program. I was messing around with this so much. Let's bring that back, actually. It's correct. There. I feel like it's understandable what I'm doing here. I hope so, anyway. Hey, Goldfish. Does not expect to be cash flow positive until 2029. There's a problem with that. So many startups are like that. And there's a reason people still invest in it. I feel like it's pretty clear. And this is possibly the most obscure syntax when it comes to functional programming that Swift has. Again, I feel like it's clear because I understand what's happening. I have the benefit of knowing the language and of knowing the paradigm, kind of. Not super familiar with functional programming, but a little bit. But yeah, I'm curious if people understand what's going on in this line of code. I feel like they do. I feel like it's pretty clear. List literal ring reduced with plus initial value 0. Yeah, that's pretty much it. Maybe the most complex part of this is the use of the word reduce, if you don't understand what that means. Reduce, map. Swift uses compact map or flat map. They used to use one, then they deprecated and changed it up for the other one, but I think a compact map is the one that they still use. Fold. The name of the function itself is not, it changes per language, I guess, but it's maybe the most complex thing is understanding what reduce means in this context if you don't understand the context. But I feel like array 0 plus produces 15. You can understand it. Can you apply plus with Swift though? So this thing? What I just did? Yeah. Register. There's a dog here, by the way. Another interesting take I saw on Twitter was that AI is actually the most pro-consumer technology ever because investors are losing money on it. So it must benefit the consumer. You cannot possibly hold that. That was rage bait. That's gotta be rage bait. What's going on here? That is, can plus take many arguments? No. Let me just Google that. A fold L. Folder or fold L is more efficient? Oh, is that like left to right, right to left? Is that what R and L stand for? Alright, Jester, I like having you here, but my foot is literally asleep. To the point that I feel like I don't even have a foot anymore. Left-right version, right? I mean, that makes sense. To be fair, like if you have a more complex operation than this one, you can still implement it like this, where this is the initial value and this is what you do. This is the operation. So plus is just shorthand for accumulator plus value. Okay, just yeah, my foot is super asleep. It's like Java kinda. Don't ever say that again. Don't ever say that again. Do not compare Swift to Java ever again. Please. They have nothing to do with each other. Actually, when I first started looking for a job, I had been programming mostly C# because I had been working with Unity. And I was like, well, C# is the language that I'm most familiar with at the time. I'm just gonna use, C#. I'm just gonna get a job doing C# stuff. And I did one interview. Java is more functional these days? Oh god. You know what? I'm just gonna ignore that you guys said that. I'm just gonna ignore those 2 last chat messages and keep my sanity. Thank you very much, because I don't want to ever say anything good about Java again. Well, ever. But anyway, I did one job interview for C#, and it was a very small company, but it all felt so enterprise. I'm not trying to insult them by saying boring, but I kind of just said it. That I took what little money I had. I bought the cheapest fucking Mac I could buy, which I dropped out of college right before this happened, so it wasn't a lot of money. But yeah, I took what little money I had. I was like, I don't need to eat this week. I'm buying a Mac. So I could do Swift. And I got a job working as an app developer, and I didn't work in enterprise. I did briefly work in a company that was very similar to that one, so it all came back to bite me in the ass. But I didn't have to do enterprise anymore. So, C# just scared me that badly. I cannot imagine if I had been doing Java instead of C#. I thought he fell. Jonathan Blow has some insane takes. He's the guy from Jai. I always want to call it JI or JAI, but that's not the name of the language. It's Jai. I've heard some takes, but nothing particularly crazy from him. Then again, I don't know him that well. And when am I creating redacted Arch 64? Tomorrow? No, okay. Look, if it was viable to make my own CPU, do you think I wouldn't have done that already? Do you think for a second I wouldn't have done that already? Chai team. Yeah, that's the thing. I was using C# for Unity. But this was C#.net. C# for Unity is... It's okay. It's okay. Let's face it, that's okay. C# for anything else? Same... Okay, fine. I'll bite the bullet. Because I was going to say for Java. that thing that I said before about somebody asking me like what should I do to learn Java, and we looked it up, and the best answer was like either make management software or Minecraft mods. It's not that hard to make a CPU as long as it's 8-bit or 16-bit. I did try to make an emulator for an 8-bit, and then I just got bored and I just started making something else on stream a while ago. But yeah, it's not too difficult, but like kind of not useful. Spent his whole career making games in low-level languages. That's where he's coming from. Based. All right, let's see. It's so boring. It's so boring. It may be functional, but it takes the fun. It doesn't put the fun in functional programming. It doesn't even put the fun in funeral. I'm sure if I tried, I could make a better joke. But I'm not gonna try. He is mostly known for saying women are less bound to choose careers like programming due to how they are and not sexism or whatever they argue. J. I was gonna say. Jonathan Blow? Damn. Not surprised that people think that. I've heard that one a bunch of times, but like, Jesus Christ. Actually, I had this one like college professor once that um first class sees that we had a bunch of girls in our class. Was like, wow, that's a lot of women. Women don't usually learn this type of stuff. Huh. Wait. Bunch of sexism. And then never showed up to class again. The guy just fucking vanished off the face of the earth. I even like got into beef with him because every time he kept canceling classes. That's a story for another day. But yeah, incredible. Open source isn't democratic by design. It isn't democratic by design, kind of. And don't know exactly where he was coming from, but like considering that one college was in Venezuela. Then I mostly studied in Italy, and I did one semester here in Spain. Um, open source isn't super democratic by um by design, I feel like, because even though something can be open source and you can technically like fork it and do whatever you want with it, it doesn't change the fact that the main source is still the original, which is probably controlled by one person. Like Linux, for example. Um, it's not mostly controlled. Well, I guess Torvalds still gets a final say in most things, but Linux is not run by him entirely now. It's um, kind of like it's a whole foundation behind it, but it doesn't change the fact that technically, yes, I can fork Linux and do whatever I want with it, but the main source is still the Linux Foundation one. He said PR contributions are less powerful than the owner of the project. Is that wrong though? When you think about it, a PR contribution is subject to approval from one person. Like you could make a pull request to my operating system, and you could fix literally all the bugs, all the to-dos, all the missing features, implement them. And if I don't want to have it because my ego prevents me from having someone else fix those things. I need to be the one who does it, and my ego wants me to do that. Then fuck you, your PR is getting rejected. And there's nothing you can do about it. You can fork the project, and your fork can even become more popular than mine. But that's pretty much not impossible, but super unlikely. I cannot think of a single project where a fork becomes the most prominent version of it. But more so than democratization, the important you can name a few. Honestly, I mean, I can't think of anything. Doesn't mean that there aren't any. When they changed the license, fair, fair. So you could use that repo. Oh wait, you're responding to an old message that you sent. I saw a cool repo for a new arch, which is simple, like long arch 64, a bit RISC-V. Pretty cool, it even has graphics. Can you send it on Discord? You can't send it on YouTube, and I might as well just check it out later. The thing is, it doesn't matter if something is democratic or not, because open source is decentralized. Kind of. The licensing thing is a little bit Chromium is a fork of WebKit. Fair. And there's like a million forks of VS Code that have their own agentic.
Democracy is a lie stone in 90 art.
The thing about it is that instead of thinking about it in terms of democratization of software, you can think about it in terms of decentralization of software. And then you kind of get the point. I mean, special licensing aside, if I like your project but I don't like you, I make a fork and I use my fork of that project. Like you have VS Codium, which is just a pre-built of the open source VS Code without all the Microsoft stuff. Because the main version of VS Code is the one that you download pre-built with a bunch of Microsoft telemetry built into it. But you can get, somebody was like, hey, I like this project. I don't like the Microsoft part of it. Let me just yoink it and pre-build my own version without it. WebKit is a fork of KHTML. Gee, we're getting into unknowns here that I didn't even know existed. So all right, there's some examples of that. But yeah, so democracy, does it really matter when you have decentralization? Because again, you see my operating system, you see that it has a bunch of to-dos, it has a bunch of bugs, and it has a bunch of missing features. You add them, you make a pull request. My ego prevents me from accepting your pull request, so I say no, fuck you. And your fork becomes more popular than mine. And even though the project was originally mine, you just changed the name of it. It's no longer Redacted OS, it's now Perfect OS, because you're so perfect. Okay. You change its name, and now yours becomes more popular than mine, even though it's built off of my project. So yeah, it doesn't really matter if it's democratic or not. That's my repository, and I can do whatever I want with it. Well, you can just clone it, pretty much. There is some licensing, I guess, which maybe prevents that, but yeah. I did testing for one project and the team split because the owner and dev didn't agree on integrating Rust into the project. That's one. I would not integrate Rust into my project. You guys rioting? Jester. Hey, buddy. Don't join in. The reason Linux has never been successfully forked is Linux is a merge machine. Does the Pi OS count? I feel like it's even used by. I saw a video by other Linus, where he talked about how Raspberry Pi alternatives often use Raspberry Pi Linux. So I guess that would count as a kind of being successful. And am I wrong to assume that most distros probably use a fork of Linux instead of just using fully vanilla Linux? That's a question, not really, I think. And Raspberry, oh, Android also. Android. Which is again kind of like not really a open source fork, but yeah. There's always patches being used, but they get upstream or die. I would consider patches. There he goes again. I don't know what you guys wanted Jester to do, but that's what he's doing instead, so. Oh my god. He's a special guy. Did he free himself from the prison? No. We'll walk when we walk. Anti-licking spray. Oh, that feels like a bad idea. It's not like he does anything particularly bad. It's not like he does anything particularly bad. It's just that recently this week he's been doing it a lot when I'm streaming. And it has gotten in the past a little bit like annoying when I'm trying to debug something and it's just like licking sounds in the background. But no, mostly it's okay. Also, there's the fact that usually I have that door open. He can come and go as he pleases, but because I have the heater on, he doesn't get to do that. My title doesn't say that. It says live coding, not vibe coding. And it's done on purpose so that it fools people into thinking that I'm vibe coding. Then they come in and they learn that LLMs are bad. No, but I am live brain coding. New term. Remember that one. Brain coding. We gotta popularize that term. All right, we gotta make that a thing. Brain coding. I'm brain coding the operating system. Yes, Next Programming is the one who came up with it. Brain coding a compiler, but I did encounter a little bit of a limitation in which this happens. If I add a while loop to it or a do while loop to it, and I couldn't really tell you why it's happening because it's not even implemented. So, wait. I'm gonna. What's weird about it is that the while loop isn't even there. So this works. Okay, so which part of this makes it break? Now I want to find that out. This works as well. What about all these function declarations? Now it breaks. One of you has betrayed me. Is it you, Judas? No, it's not you. What would be in the mind of the individual who wrote the first ever compiler, and how would have you compiler if it wasn't anything before? There was assembly before. Before assembly, there were punch cards and shit. Still haven't found Judas. Okay. Is it you? You're the Judas. Alright, Jester. Relax. Terry Davis is the answer to your question. Actually, before computers, computers were just people who did math. Then we went to punch cards. And after punch cards, we got well, I guess assembly, which is just a kind of mostly one-to-one representation of binary. And then kinda what you could have done is you wrote a compiler in you designed your language without a compiler for it. You just designed it. You just wrote the damn thing. Kind of like I did here. This is what I want my language to look like, kind of. But it wouldn't compile right now, probably. More and more it might be able to compile, but not quite yet. It wouldn't be able to compile this type of thing, for example, the do type of thing. But you wrote your language, you wrote your compiler in your language, and then you manually compiled it. Which sounds painstaking, probably took a lot longer. But also, languages were a lot simpler than they are now. You wouldn't have a lot of really complex stuff. They were really close to the hardware, so there was a lot less compilation being done because there was a lot less abstraction being done. For that matter, when I first started writing actual code for my compiler to compile, I talked about how a for loop is just a label, an increment, and an if statement, which in terms of assembly is just a conditional check, however your assembly language does that, an increment or an add, however your language does that, and a jump or a conditional jump, however your language does that. So you start out with something that simple, done in assembly, as hard-coded as possible, and then you can build newer versions of your language with the language that you already have. Assembly, more than compiled, you could say gets encoded-ish, because most of assembly, let me pull up some assembly. Most of assembly has a direct translation to binary. As a matter of fact, I have a little bit of a, and I'm not using it right now, but it is there, a decompiler for assembly. So it takes raw instructions and translates them to their meaning in assembly. And that, did I delete that code by any chance? That would be stupid to delete that code. I'm hoping it's still there. Yeah, all of this. So this is a mask, right? Essentially, you take a instruction, which an instruction is 32 bits in binary, and you use this mask to get rid of anything that you don't need from it. So you zero out anything that you don't need in order to check an instruction, and then you compare it against this value. So if the instruction starts with A98, then it's an STP, which is a store pointer. Don't quote me on the name, but that's kind of what it is. If it's 528, then it's a move instruction. If it's a 1-1, then it's an add. So binary is just that simple. You can just decode instructions. And then you can easily encode instructions. The most complicated thing about assembly is labels, because assembly actually does have go-tos, and it's not complicated at all, but it's maybe the most complexity that it has when it comes to actually like compiling it as a language. It's the fact that you can have labels like this. So do I have an assembly? No. Or ARM, maybe? Also no. Either way, you have these kinds of labels and you can jump to them. So, not sure why this is called half. I think it was supposed to be halt, but I somehow misspelled it as half and I didn't realize. This label just simply says, hey, keep track of this position. And this label says, jump to the position that you were keeping track of. That's the most complex part of an assembly compiler, really, as far as I can think right now. That, and maybe the fact that nowadays they support this kind of thing, like external symbols that are kind of hard-coded, which are labels in C. Or wait, these are actually labels in the linker. But anyway, labels in x86 probably gets quite more complex. But the thing is that compilers were built progressively. If we had to start over, a compiler for C in pure punch card ones and zeros, you'd go crazy. The best way to do it, if you really had to start over, like cold start compilers from the very beginning, we lose all computer data and all written computer data, like books about it too. We lose all of that. We forget about it too. And we just have to start over. We just know that we want to do that. You would be better off just doing what they did back then too. So first, start with a compiler for assembly. Then write your C compiler. Well, no, a subset of C, like the one that I wrote here, that is Turing complete. Create that, design it in pen and paper. Once you have defined it, build a compiler with it for itself, and then build the first version of that compiler in assembly. So manually do the translation, which you build the compiler, so you should know how to do that. Because you know the steps that the compiler takes, you just have to take those steps manually. And then you have the first version, you can compile your language, you can then compile more versions of the language. You want to expand it? Cool. Write whatever code you need for the compiler to support the expansion in the current version of the language and use it to create the next one. It's an interesting topic. Okay. Probably time to end the stream. However, I am still so confused by the fact that this fails. So I kind of want to look at what's happening log-wise. With this instruction, if do while is there, now it works. Are you serious? Oh, but there is something weird happening. Maximum depth reached. Too many nested statements. Shame on you. Which is a technical limitation of my compiler, but makes you wonder, why is that there? It eventually manages to work, but very clearly something is going wrong. And this is exactly why in the parser I built this that just goes step by step. Function declaration. It's not a function declaration, I can tell you that much. No, it is a function declaration. You should parse it as a function declaration. In every version of your 100% memory safe language, malware will always be self-replicating in every version of... What's that in reference to? Because I understand the reference, but I don't remember what you're referencing. Is that a real thing that happened? I think like it is. I don't remember. I've heard this before. 80% sure I've heard it from Lori Wired. Not sure what it references. Ken Thompson. Okay, so it feels like we've already gotten quite weird here. Can I... Where's my rules? Rules.config. Okay, I don't know why I couldn't see it. You just have these two real quick as valid. Void B function arguments. Yes. Fails though. Fail. Okay, succeeded. Block is happening in here. Jester, you've literally not stopped licking yourself since you woke up. Come on, man. Backdoor into the binary, Jesus. If you don't have the source of the first compiler and you use self-hosted compiler to compile the new version, then you almost never could find the backdoor in it. Good point. But it's the question is it a thought experiment or is it an actual thing that happened? I feel like it's a thought experiment. Even like this, it's hard to tell exactly what's happening. But it failed to detect it as a function declaration. Well, not super enlightening on what's happening here. Couldn't really tell you. And I've already undone too much of my compiler. So I'm just gonna get rid of that rule for now. I'm going to restore street cred to its former glory in the messiest fucking program ever written. It's literally what happened. Jesus. Line 13 now has an error. Oh. For loop is missing. There we go. All right, we're back to being able to compile, and we're going to end the stream here. Wait, no, hold on. I want to finish looking at this, but I'm done coding, so I'm just going to quickly commit what I have. You don't get to be committed. What else did I add? For loop. That's it. Okay. You can't trust code that you didn't totally create yourself, especially code from companies that employ people like me. Built and not distributed. Okay, this website is not loading for me. Why is that like the second time that it happens with a link that you sent me? I don't know why. But so he built a compiler like that, but he didn't actually finish it. Jors. I was gonna write Jors. Compiler-based Trojan horse reflections on trusting trust. That time Ken Thompson wrote a backdoor into the C. Is that the same website? It is also not loading. What's going on here? Reddit loads. Oh god, why is the text so big? He finished it, but he didn't push it into the wall. That makes sense. There are backdoors in CPUs, like Jesus. Sometimes software is crazy. The anime crap made me feel so uneasy I had to delete it with DevTools. I'm glad I went to the comments and not kept reading the article. Kinda got a feeling. I probably shouldn't do that. Yeah, the thing is, he did it theoretically. Can we know, with a million languages being made out there, that not everyone, that other people aren't doing it? We can read the source code and build from source, but can we know for sure? We have to read and fully understand everything we look at. Invest millions of dollars to Arch to rewrite package manager in Rust. Was it, which distro was it that replaced a bunch of core utils with Rust, and then they found a bunch of CVEs and bugs and whatnot? People complained because fucking obviously they did. The backdoor is not in the code. I kind of forgot how it works. It's a whole thing. It is Ubuntu, right? Yeah, but not the version I'm using. Thank God. But it was Ubuntu. How to prevent this type of attack? Called diverse double compiling. I do remember also that this was it Lori Wired. I'm pretty sure she talked about this. Not passing basic tests. Are you serious? Oh, this is the video that I was talking about. I forgot why I was talking about it, but I was talking about it. This is the one. This is the one. This is the video. The original sin of computing that no one can fix. Also, Computer File did a video on it. And a lot of people did a video on it, clearly. But yeah, not going through them right now, but I'll check it out again later because I do remember it, but I don't remember how exactly the attack is supposed to work. To hand compile your C code. Makes sense. I guess I'll have to do that. You would have to build your own hardware too. And the funniest thing is that maybe you won't have intentional backdoors, but you will have a bunch of unintentional bugs and vulnerabilities. That maybe you don't even need to like have someone else exploit them. Just the bugs themselves are enough. Not that I know anything about that. Mine your own silicon to make transistors and build your own laser. The dream. The dream. And power grid. Yeah, maybe that's not the dream. You didn't get shadow banned. I can see your messages. Yeah, the Intel had a fucking predictive programming, predictive branching, whatever that's called, vulnerability, where essentially it thought that things were gonna go one way, so it started loading memory in order to make things faster, because it was predicting that certain code was gonna run and certain memory was gonna be accessed, so it was accessing it ahead of time, and then it became available. I believe that was kind of the gist of it. Kind of an insane vulnerability, but also kind of insane that they're doing predictive shit like that. Great. Just wait till at least one manufacturer is going to try to come up with a AI powered CPU. We already have AI powered GPUs, but we're definitely gonna get AI powered CPUs, and it's gonna be so fucking funny if they don't switch us all to cloud computing, because why should we own our own hardware before then? It's gonna a race for which one of those comes first. And either way, I don't want either one of them. Auto updates in Ubuntu was failing because of absolutely not compatible date utils and cult core utils. Jesus Christ. I have an AI CPU. Technically, all it does is just ask ChatGPT how to respond to CPU instructions. Like a gimmick thing, you mean, right? It's a QEMU fork. Also, I saw on Twitter, not a vibe coded OS, but just the entire thing happening in AI. The entire OS is AI. You're just asking ChatGPT to generate an interface for you real quick. Kind of like that one game of Minecraft that's it just generates the next frame based on what's more likely to be there. So if you know that game, kind of like that, but for an operating system, but also responding to user input. And they were like, this is the future of operating systems. And it's so funny that you can never tell who's joking and who isn't on Twitter, because blue check marks get paid for engagement, so rage baiting is profitable. But also, they're really, really stupid. So it could really go either way when you see something really stupid on Twitter. It could be rage baiting, or it could just be that stupid. Kinda TikTok as well, but less so. Hey, Dragon. AI OS, I cannot imagine. Copilot OS is coming out, probably. Oh, I don't have... Who is? It's not a pre-built? Damn. I'm not about to install it. It's a pre-built on Mac, so... It's owned by Redacted. I didn't even know I owned that domain. No, it's redacted for privacy. Damn, it's actually been owned for 20 years at this point. If I'm reading the date format correctly, January 3rd, 2006. So, damn it. Somebody got ahead of me by 20 years. You know how my OS's name is redacted? It's not anymore. It's now Copilot. I'm joking. I'm joking. I'm joking. It's Cursor. First CV in Rust Linux. You will be amazed by how shitty this code is. I knew it. That person on Twitter was not rage baiting when they said if it compiles, it probably is fine. Do Rust users genuinely not consider logic bugs? It's impossible to think that your code has worked every single time. Sometimes I've seen people say that, oh, you know, Rust is packages in Rust aren't abandoned. They're completed. No more updates are needed. No. That's not true. It's abandoned. It's fucking abandoned. By the way, I've also heard of CVEs in Rust code that is completed but not abandoned. Because it is abandoned. So I've also heard of that one. No, I was kind of hoping that it was a joke, that they do consider logic, but I really don't think they do. I mean, some obviously do. Like, just because you write Rust doesn't mean that you're like that. It's just that, bro, come on. They heard that one stat from Google that was like 70% of vulnerabilities come from memory overflows. And they're like, well, there's no memory overflows in my language, so all vulnerabilities are gone and all bugs as well. What are you talking about? Few people really know or are old enough to know Rust's true secret. Back when it was iron? What is it? I have no idea. I've heard of Rust for a while, but I've always thought it was kind of ugly. The syntax of Rust is so ugly. I have it here, but I'm not gonna use it. I'm actually gonna end the stream soon. This is the prettiest it's gonna get, by the way. This is a macro. By the way. I use Rust, by the way. No, I don't. By the way. I use Ubuntu, by the way. I use C, by the way. I use Mac, by the way. I use Swift as my memory safe language, by the way. Okay. I'm kind of waiting to see if you're gonna reveal Rust's true secret. Now I'm interested. The clickbaiting has baited me. But I am gonna end the stream. I'm gonna walk this motherfucker that's actually perched on the edge of the bed, waiting for me to get off stream so I can walk him. Oh, he laid down. But yeah, him. Called solved all CVEs using C code, by the way. Just rewrote it in Rust and auto-closed all CVEs related to written code. The 10 most broken secrets in Rust to become an elite player. I know that's not it, but... Rustin Spencer? Whose name is Rustin, bro? What the hell? The joy of Rust. Let mutt x equal alloc colon I3210. It's like they took the worst part of every other language's syntax and they just put them all together. C++, Swift, also Swift technically does let means const and mut means mutable, so I'm assuming let means something else here. This code violates all Rust borrow checker rules and no unsaved used. Well, you intentionally broke it. It's kind of like to be expected, I guess. It's so ugly. A+3? You can just do that? What in the name of fuck did you just do? Okay, it doesn't look like you went particularly out of your way to break it. This is pointer. If it's the same as Swift, so not Swift, C, then this is pointer to X and Y is being assigned to X but as a pointer, so it points to the same value. God damn. That was easy. Rust did get C-fied as it evolved. Hey, Dever dummy. Safe is safe pointer. But that's not being used, is it? Or am I missing it? Oh, here. Oh, it's used here as well. Very safe, I'm sure. The linked list one is quite long, but this one, let me see. Immutable alloc, no. freeing it, then assigning to it. Use after free possible? No? Yes? Really? I'm assuming it prints yes. Isn't this exactly the stuff they tell us that Rust prevents you from doing? I thought when I opened this, I immediately said you went out of your way to break Rust. And now I'm reading the code, and you did not go out of your way to break Rust. You just wrote Rust. No, no, no. Learn. Playground, playground, playground. Oh, there's no function alloc in here anyway. Do I need to import something? Do I need to do anything? Oh, you have a playground yourself. 4-bit unsafe code. And here's all of them. X20, Y20, you don't understand 7, multiple references works, use after free possible yes, really yes. I didn't read the linked list code. But you have an unreachable node there. Rust doesn't prevent you from doing anything, you just have to annotate that you did it. Where's the annotations here? There's none of that happening. Also, shouldn't it prevent you from doing stuff? Isn't that the entire point? I'ma just keep quiet. So yeah, I'm taking it back. You did not go out of your way to break Rust. You just used it and it broke itself. It should prevent that type of stuff. Isn't that the entire point of Rust? That's what the entire cult keeps yelling about. That is pretty much the entire reason to use Rust. This syntax is fucking horrifying, by the way. It's either normal code syntax or horrifying syntax. No in between. So if on top of that, it isn't even that easy to break the safety of it, I don't know what the point of Rust is anymore. CPP feels amazing to write. I don't know about that one, but all right. Oh, yeah, it's okay. It's okay. I give CPP a lot of shit, but honestly, it's nice. Okay, I am gonna end the stream here. I am gonna end the stream here. End the compiler work for this week, most likely. Tomorrow, the compiler does work. I'll see if I manage to fix the issue with the do while and the while loop. Which probably takes a little bit of debugging, you know, narrowing down the issue a little bit. And now that I have a clean working tree, I can just nuke anything that I don't need, isolate the problem, probably find a way to fix it pretty easily. But either way, the compiler does work. It compiles. It produces not super correct, but it tries to produce kind of correct C code. The thing is, it did produce correct C code, and then I went and ruined it by saying something stupid like "I love you." So my bad. for doing that.
Neovim is the best code editor. K.
Yeah. But I should finish the stream in the next 45 minutes. 45 seconds, I mean. All right, I should like clean up the code generation a little bit so that it works properly, but the code generator works. It just hasn't been updated with the new rules that I added after I made it work. So it's something to do off stream. Not sure if I'm gonna have time to do it by tomorrow, but either way, tomorrow I am planning on doing the operating system stuff, and we're definitely gonna have an ad break. Well, we're definitely gonna have an ad, and I might as well talk about what I said I was gonna do with the operating system, because I said I was gonna combine the two, right? So yesterday in the operating system, I added proper support for arguments because it technically handled them differently than Linux does. In Linux, argv0, so when you call a main function, you have argc indicating the number of arguments and argv indicating the actual arguments. Argv0 is the name of the program, whereas in my system it used to be the program itself. Well, it used to be the first argument, I mean. So that little inconsistency would make it a little bit difficult to port things between the two programs. But now it should technically be possible to run my compiler in Redacted OS. And if it's possible to run my compiler in Redacted OS, then that means my system officially has a compiler. We'll see. But my compiler doesn't generate an executable, it generates C code for the time being. And for that matter, it is kind of a prototype compiler. So maybe this version of the compiler won't even generate actual code. The issue with the loops is due to the nature of your rules, most likely. I just need to isolate it to see what's happening, but yeah. I feel like, yeah, the recursiveness of it, or it's somehow not detecting while and for, and so kind of like mistakes a function as a loop. I don't know. But it's weird because it should detect a function as a valid function first and as a loop second. But yeah, I don't know. I guess I'll see what's happening. But yeah, maybe it being recursive could be it. I'm not sure. And I do not have a video explaining CRED because I haven't finished it yet. Frankly, once I fix this bug in the parser, which is the first one that's really appeared in the parser, and once I make the code generator be able to fully generate all the code that I needed to generate, which is pretty much the rules that I added today plus type defs, then I can consider version, let's call it 0.1 of the prototype compiler finished. I'll change its name because CRED is the name of the language. And this compiler isn't specifically built for CRED. It's built as a prototype compiler, as a bootstrap compiler. It's built as the first version of the compiler that's written in a different language. And it compiles to C. Maybe it'll compile to CRED too. I can make a CRED backend for it. And then it can compile itself and create a CRED compiler. We'll see. We'll see how crazy we can get, how recursive crazy we can get with it. But we'll see. Either way, it technically is able to compile to C, and right now as a backend for that, I have GCC. Right, it compiles to C. It needs to be able to compile that C somehow. And so I was thinking, since I do have this output.c file that gets generated, you could just GCC output C, output O, and there you go. You created, you compiled your program. Well, besides these missing functions and these missing symbols that broke at some point or another. So yeah, once the bug fixing is done. But either way, I've mentioned wanting to make my operating system kind of distributed, and I wanted to make it be able to communicate with other systems. And so I was considering if we should start designing that using the compiler as a target. Essentially, the compiler creates the .c, similar to Plan 9, yes, but I'm going a little bit more command-oriented, perhaps? I don't know. The thing is, I haven't been able to test Plan 9 as a distributed system yet. So maybe tomorrow I'm going to do more research about this topic more than implementation. But yeah, essentially, the compiler takes the code inside of Redacted OS, compiles it to C inside of Redacted OS, and then sends that to another machine to be compiled by GCC, and maybe it receives the executable back, or maybe just the executable is there produced. I do use 9p protocol, so I technically have a little bit of networking capabilities like that, but it's currently only used by QEMU, a 9p VirtIO device. But yeah, that's a thing. That's the thing. I don't have GCC ported to RedOS. That's why I'm saying I want to implement distributed using this, because maybe I could port GCC, sure, but then I would also have to port the GPP, or no, is it G++ compiler? Well, the one for C++. And I will also have to port the one for assembly, and I would have to port GDB, and I would have to port any other program. Or create, like I said, this system for distributed operating system, which I've been wanting to build for a while, but I haven't really had any reason to. So now I actually do. So kind of consider what I would want to be a server, which doesn't necessarily have to be in Redacted OS. It can be in Linux or Mac or Windows, and just Redacted OS can send commands to that server, can be like, hey, I have this file here, can you compile it for me using GCC? And it can do that. Right, so what would that server infrastructure look like? What would it wouldn't really be client server, because those are two very specific type of behaviors. Whereas instead here, it's more like sometimes this one acts like the server, this one like the client, sometimes the other way around. But either way, kind of design that architecture a little bit, do a little bit of research. I haven't been able to test Plan 9 on distributed, and I don't think I will be able to. For that matter, I can't even get networking to work on Redacted OS on Linux. I have it on Mac, but not on Linux. And to test it, I tried once, it didn't work, and I never tried again. But it probably will be necessary if I want to get into distributed. But tomorrow I'm going to do the research part of it, you know, designing the system, kind of decide how I want it to work, how I want them to communicate and all that stuff. And then after that, use this server infrastructure to offload work onto Linux, Mac, Windows, anything else, other redacted systems, and make it distributed like that. So that's the plan for tomorrow. Tomorrow we're going to research distributed operating systems, I guess. I don't know if we're gonna do any coding related to it. Maybe not. Maybe I'll try to port at the very least, probably, the compiler. I'll give that a try. Yeah, I'll give that a try, most likely. But that is it for today. I'm going to link my Twitch for the YouTube viewers who want to join us on a raid. And I'm going to start a raid real quick on Twitch. There are people that I'm following, so yeah. All right. Okay, going to end the stream on, well, on both platforms in a second, but see you tomorrow. Well, I'm also gonna link my Discord. I can kind of have been remembering to do that lately, but hadn't been doing it for a while. So there's the link to my Discord in case you're interested in joining, keeping up. Next stream is in 23 hours. It's at 7:30 p.m. Central European Time. It's 6:30 UK time. And I'm going to start a raid now, so I will see you tomorrow. Wait, it's not starting yet. Just a second. God damn it, why is there a delay? There we go, see ya.